Hey everyone, I welcome you to this amazing course on Azure DevOps, where we'll embark on a journey through the dynamic world of modern software development and collaboration. In this course, we'll explore the powerful tools and methodologies offered by Azure DevOps designed to streamline the development lifecycle and enhance the team productivity. Throughout this course, we'll delve into a comprehensive understanding of Azure DevOps, covering topics such as version control, continuous integration, continuous delivery, and much more. Our goal is to equip you with the knowledge and skills necessary to effectively leverage Azure DevOps for successful software development and deployment. From managing code repositories to automating building and deployments, we'll navigate the intricacies of Azure DevOps, enabling you to optimize workflows, improve collaborations, and ultimately deliver high-quality software product efficiently. This is the outline of the entire course, and these are all the sections that we are going to cover throughout this course. So firstly, we'll see a brief introduction of the course, then we are going to set up our project space in Azure DevOps. After that, we'll have a look at some of the key features of Azure DevOps. After that, we'll move towards more complex features such as source control with the Git version control. After that, we will see how you can implement continuous integration using TFVCs and Git repository, and then finally we are going to deploy our application on a virtual machine. The course comprises of approximately 25 labs ranging from the beginner level concepts to the advanced level. So we'll start by setting up our workspace in Azure DevOps. After that, we'll see some features of Azure DevOps such as boards, repositories, pipelines, artifacts, and test plans. After that, we'll see how you can perform source control or the version control with the Git, in which we will see how you can create branches, how you can manage the merging conflicts, and how you can manage the pull requests, etc. After that, we will see how you can perform continuous integration by creating build and release pipelines, and then finally we are going to automate the deployment by setting the triggers to trigger the pipelines to deploy the code on the virtual machine. Meet our team who played a role in creating this amazing course for you, and together we have more than 40 years of experience in practical implementation of technology as well as teaching technical courses at university level. Let your creativity soar and let's embark on this adventure together in the captivating world of Azure DevOps. I hope you're going to learn a lot from this course. Welcome to Azure DevOps. Throughout this course, we are going to see everything about Azure DevOps from scratch. So if you are a beginner and you have no prior knowledge of Azure DevOps, then this course is perfect for you. So I am going to start the course by explaining what exactly is DevOps. But before DevOps, let's have a look on how software development works. So let's discuss a basic life cycle of the software development. In the starting of everything, you have to make a plan. Once your plan is ready, you have to write the code, and once you are done with the code, then you have to build your code so that you can give it to the testing team. Then the testing team will test the product. After that, it will be deployed on the server. Once the code is deployed on the server, there are some operations which needs to be performed. The last one is the monitor. Someone from the team has to monitor what exactly is happening on the server. Does it need the scale up or the scale down, or do we need to increase the server capacity, etc. So all these things need to be monitored on the server. So if you are working in a startup company, or you have a very small premises, or you have very small number of members in your team, then all these things are done by the same team. The same team will work on the plan, the development, the deployment. But if you are working in a big organization, or even if you are working in a small organization and still your organization follows some process, then things are a little bit different. How? All these steps are done by different teams. So first we have a team for the planning of any project. So we can say that this team comes under the business team or the product owner. The product owner sits with the client and he works on planning part of the product. Then we have the development team. The development team includes developers and the testers. They code, build and test the product, and then at the last we have the operations team. The main work of the operation teams is the deployed code on the server, monitor it and operate it. So right now we can say that we have 3 teams working on a particular product deployment. Earlier when we were working in the waterfall model, then all these teams were working independently. When Agile came into the picture, the gap in between these 2 teams were filled or the business team or PO and the development team were working together on the success of a project. Now we have more than one team. It is operations team. Still there is a gap in between these two teams, which are the development team and the operations team. So here comes the DevOps in action. So now let's understand what is DevOps. DevOps is something where the development and the operations work together. So we have the dev from the development and ops from the operations. Hence we have a new word which is DevOps. So you can understand that DevOps is something related to the development team and the operations team. And there is a plus symbol in between them. It means that they will work together. Basically, the DevOps fills the gap in between the development and the operations. Just like Agile did to the business team, the PO and the development team, same thing is done by the DevOps for the development and the operation. Let's have a look on few points of what is DevOps. DevOps is a culture or practice. This is very important to understand. DevOps is a culture or practice which fills the gap between development team and operations team. If you are thinking DevOps is a tool, a process or methodology or any technique, then it is not true. DevOps is basically a culture. It is a practice both the team works together in entire software development lifecycle to ensure the quality of the product, the ability of the product to work in different environments. Let me tell you a very general statement from the development team. So what happens when a particular developer develops something and he gives it to the tester for testing? And if something is not working in that environment, then there is a general excuse, or we can say general statement for the development team that this is working fine on my system. I don't know what is happening on the other end. It means that there is some problem related to the environment and this gap is filled by the DevOps. In DevOps environment, both the teams work together and they focus on the environment, the quality of the product, and there are different aspects that we will learn in the later part of this video. All these points are taken care by the DevOps. Lots of tools are available in the market to automate this process. To work in the DevOps, there are multiple tools available from the market and you can choose any one of them as per your requirement. All of these tools have their own configuration, their own price. Some of them are free and some of them are paid. But all of them have a feature to automate your process. Ultimately, all these things happen in an automatic way. DevOps help us to run the lifecycle on each commit or particular interval by using the automate process. So what is the meaning of this line? If you talk about the overview of the software development lifecycle, what happens? Initially we plan, we develop and we deploy. But if I say that all these processes will happen on each commit you made to your code, so whenever you are working on a Git repository or any other code repository and you commit your code, and you simply push it, all the steps happen there automatically. So whenever you push the code, it will build automatically, it will test automatically, and it will deploy automatically. And other operations which are available there will happen automatically. So basically, we are taking care of each commit of the software development to ensure the quality and other aspects of the product. So that was all about the introduction to what is DevOps. Now we have another question. Who should learn DevOps? Each person who is working in a software development team, that is developers, testers, product owners or Scrum Master, etc., all the members who are working in the development team needs to learn DevOps. DevOps is irrespective of your technology. If you are working with .NET or Java or PHP or Angular or any other technology which is available in the market, then DevOps is for you. Then we have the operations team. So obviously the operation teams and all the members of the operations team who are responsible for the deployment, the management and monitoring all those things, all the persons from the operation teams must learn about DevOps. Next, we have the individual developers. So if you are not working in a team and you are individual contributor on a particular project, still you need to learn about DevOps because it is going to improve your process, your speed of development, and all these things are going to improve a lot if you use DevOps. Then we have the freelancers. If you are a freelancer and you need to manage your code, so sometimes what happens, you write your code in your system and because of some reason that system crashes. Then what will happen? You will lose all your code, all your planning will be lost. So what will happen if you manage all these things on a particular server, then everything will be available to you every time whenever you will access. that server from any machine, then all the data will be available to you on that machine, irrespective of the type of the machine. And then finally, we have the management. The management team must also learn about the DevOps. This is because whatever the development team is doing, then they can get a clear picture by looking at few graphs and the details of the work which is going on. Hence, management teams should also learn the DevOps. And the most important person who should learn about the DevOps is the client. So if you're a client of a product and some team is working on your product, then you must learn about the DevOps, because you can get a clear picture of what is going on in the development. You can see the progress with the help of multiple graphs, with the help of deployment, how many bugs are there, how many stories are there, etc. These points are taken care by the DevOps. So if you are a client or someone who is related to development of something in any way, must learn DevOps. Now let's see what are the benefits of DevOps. First one is the fast delivery. Deploying code from the development machine to the server is very fast. So basically, developer has to commit the code, he has to push into the particular repository, and all the process of deploying the code will be automatically done. So it is very fast deployment on the particular server. The next benefit is reduced time. So lots of things like testing, deployment, rollback, etc. are happening automatically. Obviously, in the beginning, you have to make some setups, we have to write some code, but once all of this is done, then everything will happen automatically, like the testing, deployment, etc. All you have to do is you have to focus on the development, you have to push your code, and the rest will be taken care by the DevOps. The next benefit of DevOps is rollback. So any release which you think should not go to the end customer because of any reason can be rolled back easily using DevOps. So what happens is you push the code and some feature which you don't want to expose to the customer has been exposed, then you can simply roll it back very easily using DevOps. Another scenario of it can be sometimes a wrong feature is checked in and that is deployed on the server. Still, in this scenario, you can also roll back your code very easily. Then the next benefit of DevOps is the quality. With lots of automatic tools, we can check the quality of code before deploying it on the server. So there are several steps that you can apply to manual testing or the automatic testing. Then all these steps can be taken care by the DevOps and can ensure that the quality work is going to the server. If there is any problem, then you can easily get to know and you can fix it and then push your code, and you can again run the entire process to make the successful deployment. Next, we have the collaboration. All teams work together to build a great product. So whether you are coming from the management background or you are coming from the development team or you are coming from the operations team, then all the teams work together in order to build a great product. And that's all about introduction to DevOps. In the next video, we are going to discuss what is Azure DevOps. But that's all for this video. I'll see you in the next one. Welcome back. In the previous video, you've learned what is DevOps, what are the benefits of DevOps, and who should learn DevOps. In this video, you are going to learn about what is Azure DevOps. So Azure DevOps is a set of modern services which is used to plan smarter, collaborate better, and ship faster. So basically, it is a development lifecycle of any product. So first you have to plan, then you have to work, and then you have to deploy. So in other words, we can also say that you should plan in a smarter way. For the success of the product, you have to collaborate better, you have to work on the code management on the development side, and lastly, you have to focus on shipping better. So Azure DevOps is a set of modern services which provides all these features. You can use all of these features or you can choose from these services as per your need or role. If you are coming from a particular role, just like the product owner, then you can work on a particular service of the Azure DevOps. Moreover, if you are coming from the development side, then you can focus on a particular service, or if you are coming from a different background, then you can choose any service as per your requirement. So in short, you can choose all of them at once or you can choose any one of them as per your requirement. Azure DevOps is developed, managed, and maintained by Microsoft. So that's why we can say that Azure is very fast, very secure, and very reliable product for the DevOps. Azure DevOps was formerly known as Visual Studio Team Services or VSTS. So if you are not new in the .NET, development, then you must know about the VSTS. Earlier it used to be VSTS, but now it is called Azure DevOps. The Azure DevOps provides a set of integrated features that you can access through your web browser. So in simple words, we can say that it is a website which can be accessed with the help of a browser and internet. Now let's understand the relationship between Azure and Azure DevOps. So Azure is a cloud solution which provides lots of services and features to help your organization in almost all ways during the development of any product by providing multiple tools and technologies. So Azure is basically a cloud solution, and this cloud solution provides lots of features which are required for your company to use for the development, for the deployment, for the management, or for other things. Now what is Azure DevOps? So Azure DevOps is a feature or service of Azure. In simple words, we can say that Azure is something very broad and Azure DevOps is a part of Azure. We can say that Azure DevOps is a feature of Azure. If we talk about the graphical representation, then we can say that Azure is something which is very big and Azure DevOps is a part of this big feature. Now let's understand the main point, that what are the services which are provided by Azure DevOps. So collectively there are 5 services which are available in Azure DevOps. First one is boards, second is repos, then third is pipeline, fourth one is the test plans, and the last and the fifth one is the artifact. Out of these 5 services, you can choose any one of them according to your requirements, or you can use all of them at once. But for the success of any product, all of these 5 services are required. Now let's talk about each of the service in detail. Let's first talk about the boards. The boards are basically used to plan your work. Here in this board, you can write your stories, you can write your tasks, your bugs, or your epics, and can manage their progress complete to do all these things. The Agile board and Kanban board, all of these things are managed in the boards. Then we have the repos. So repo is basically something related to your code. In these repos, you can use the TFS repository or you can use the Git repository, and using them you can manage your code, you can create branches, you can create multiple repositories. In your project, you can use all the features which are available from the Git. So repos is all about maintaining your code inside the repositories. So then comes the pipeline. So pipeline is something related to the deployment of your code. So all the tasks, the automation process, the CI/CD, everything will be available. Then we have the test plan. So basically testing is also one of the main feature in the development, and the automation testing, the manual testing, all these things can be taken care in the test plan. At last we have the artifacts. Artifact is basically a collection of your packages which you are getting from the private repository or the public repository which you can share among your team members. And all these artifacts are required for the deployment also. So basically in the artifacts you can store your packages which are simply required for the development. So that's all about Azure DevOps. In the next video, we are going to see how you can create an account in Azure DevOps. But that's all for this video. I'll see you in the next one. Welcome back. In this video, we are going to see a comparison between the waterfall methodology and the agile methodology. In this video, you are going to see a SWOT analysis discussing the main features or characteristics of both of the methodologies. So let's start off with the waterfall method. So waterfall has been the traditional method for delivering products, delivering softwares in general. So with waterfall, you can say that everything is pre-planned. So research is done in detail before the actual project starts, and timelines and cost estimates are also predicted beforehand. So everything related to the project, the timelines, cost, how the project must flow, how the project should flow are predicted beforehand. So you can say that in waterfall model, everything is planned and discussed upfront before even the project starts. If we talk about the opportunities, one of the main opportunity is that when the project does start, each and every person or each or every resource which is somehow involved in the project already knows their role and exactly knows everything during the actual implementation or the execution phase. So all the roles and all the resources will act according to the plan that has been defined before the project actually started. But this waterfall method also has certain disadvantages. So the major disadvantage is that despite of planning everything upfront before even the project starts, but you might not be able to plan for every failure, every contingency beforehand. The second disadvantage of waterfall maybe that it is very rigid and all the steps must be followed according to the plans. But if any step of the plan causes a failure or disturbance in the any other plan, then that might not be seen before the project start. Everything needs to be changed from the beginning. If we talk about the threats related to the waterfall method, then the biggest threat that can be caused by the waterfall method is that it can lead to cost overruns and unbudgeted costs for unforeseen circumstances. This means that even though you have planned everything beforehand, but sometimes due to some unforeseen circumstances, your time duration may exceed or your cost may exceed because of certain failure or certain disturbances in any step of the whole method, then all of these may result in cost overrun and time overrun. So if we talk about an example of how you can represent the waterfall method, so the Gantt chart will be the appropriate example. So in the Gantt chart, you usually schedule everything beforehand. So you can see in this example that there are 8 different tasks and the duration of each task has been predefined. So let's say that task 1 has a duration of 2 weeks starting from the week 1 and 2, and then by the week 2 we will going to start the task 2 and it will continue up to the task 6. In the meanwhile, the task 3 will also be started but it will finish in the week 4 and so on. So like I said, everything has been planned beforehand and is expected to follow the defined plan. So if something happens and causes the delays in the execution of any of these tasks, so let's say that task 1 is assigned 2 weeks to be completed, but instead of week 2, the task 1 is completed on week 3. But since this task 2 is dependent on the task 1, so task 1 will complete on week 3 and up till then we cannot start the task 2 and task 3. This is because they are dependent on task 1. As we have already discussed that the waterfall methodology is very rigid, so let's talk about a more flexible methodology, which is the agile methodology. So in agile methodology, we have multiple teams working on smaller pieces of the product, and that may contribute to quicker release time of the product or the chunks of the product. So instead of trying to release everything at once, with agile methodology, we'll actually be delivering the product in chunks. So instead of delivering the task 1, task 2 and task 3, we'll say we have the deliverable 1, deliverable 2 and deliverable 3, etc. So the stakeholders might actually start using the portion of the product that might be delivered to them and will integrate it with the next deliverable, and so they can have a working product before the time which is given to them for the delivery of the entire product. So the most important opportunity of the agile methodology is that the business and development teams work side by side. So there is no such scenario that business team is unaware of what the development team is doing or vice versa. Since both the teams are working side by side, so they are fully aware of the progress of each other and hence there is no disturbance in the working of the either team. Moreover, they can easily collaborate with each other and decide what should be delivered after each iteration so that they may be on the same page. And since the agile is working on multiple deliverables, so organization can deliver value more quickly. This means that a minimum working prototype will be available to the client much quickly, and then all other features might be integrated later on, but the initial working product will be delivered much more quickly. But one of the weaknesses is that if the requirement gathering is not done properly, then you might end up having multiple iterations over the same deliverable because the client might not be satisfied by the end product of that iteration. This is because the requirement gathering was not done to its fullest. And the biggest threat related to the agile methodology is that it can lead to cost overrun through repeated iterations to get the bugs fixed. So one of the main reasons of cost overrun might be that you are working on multiple iterations for the same deliverable because the client might not be satisfied. This can lead to cost overrun, and the second reason might be that the deliverable of one iteration caused a bug in the deliverable of any previous iteration, and fixing it cause cost overrun. So all of these points should be kept in mind in order to choose the right methodology for your product. So in short, There is no better methodology. Both of them have their own advantages and disadvantages, and you have to choose either of them according to your own needs. So that's all for this video. I'll see you in the next one. Welcome back. In the previous section, you learned all about DevOps and Azure DevOps. Now in this video, I'm going to show you how you can actually create an account in Azure DevOps. In order to create an Azure DevOps account, you have to open your browser and in the search bar, type dev.azure.com. Once you hit enter, you will be redirected to a page that looks something like this. If you take a look at the URL, you can see that we wrote dev.azure.com, but here since we have not created any account of the Azure DevOps, so we are redirected to a page azure.microsoft.com, and inside this we have products and then we have the DevOps. This means that Azure DevOps is a product of Microsoft, as I've discussed in the previous section. So now in order to create an Azure DevOps account, you have two options. First one is to start free and the second one is to start free with a GitHub account. So if you have a GitHub account, then you can click on this option, but I'm going to simply click on start free. After that, it will ask you to pick an account associated with your Microsoft. So I'm going to click on use another account, and here I am going to provide the email ID for my account. Then click on next. Here it is showing you that we are updating our terms, and then simply click on next. Once you click on next, you will be redirected to a page that looks like this. Here the title is Get Started with Azure DevOps. So here you have to provide different things. First one is going to be the project name. It has by default selected the name from my email ID, so I am going to remove these numbers. You can go with the default value as well. Then you have to select the project visibility. You have private and public, so I'm going to leave it to private. Then you have the option to select your country or region, and this region is going to be the region closest to you. So if you scroll down, I am currently in Pakistan, so I'm going to select it. You can select any region where you are working, and then you have to pass this test. So once you do that, simply click on continue, and it will be redirected to a page that says taking you to your Azure DevOps account. It is going to take some time for loading, so I'm going to come back once it has finished processing. Okay, so it has finished processing, and now it has redirected me to a page that looks like this. So this is my Azure DevOps portal, or the home page of the portal. You can see that here you have different options in the left navigation menu. Firstly, we have the name of the project which we selected while creating our Azure DevOps account. This is the default project. You can create others from here as well. Then you have other options like overview, summary, dashboards, boards, repository, pipelines, test plans, artifacts, etc. I am going to go inside the details of each of these individually. But for now, you simply have to see that these are the options available to you. If you look at the URL now, it has changed to dev.azure.com because we have signed into the Azure DevOps. And the first thing is your organization ID. So by default, whenever you log in to the Azure DevOps for the first time using the email ID, then the first part of the email ID is selected to be created as an organization. This is because you always need an organization to work in Azure DevOps. So this is the first part of my email ID, which is the organization name. Then I provided the project name to be this. And so here it is a project name, and then you have other values for the account. So this is how you can create an account in Azure DevOps. In the next video, I'm going to show you what is an organization and how you can create and manage organization in DevOps. But that's all for this video. I'll see you in the next one. Welcome back. In the previous video, you saw how you can create an Azure DevOps account. Now in this video, I'm going to show you how you can create and manage organizations in Azure DevOps. In Azure DevOps, there is a structure of your work. And whenever you are working in Azure DevOps, you have to work smartly. This means that you have to make a good plan to structure your work in Azure DevOps. So how you can create the structure? This structure basically depends on organizations, projects, and teams. Basically, whenever you will be working on a project, ultimately you will have to work with a team. And managing a lot of projects and a lot of teams along with all their roles and members, then you have to work with organizations as well. So you have to plan your work in a structure where you have to work with organizations, projects, and teams. So basically, an organization is a mechanism for organizing and connecting groups of related projects. So if you are working in a company and that company has a lot of projects, and if you are using all those projects in the Azure portal, then managing all of the projects at once is not an easy job. So what you can do is you can create multiple groups for that project or for all those projects. And then for each group, you can create an organization. So on top of everything, there will be an organization. The organization will contain groups, and inside the groups, there will be n number of projects. This means that you can associate any number of projects within an organization. And each project will have a group and a team, but we are going to discuss all of these later on in this course. But on top of everything, there will be organization. And in order to work with Azure DevOps, you must have an organization. This means that each project must belong to an organization in order to work in Azure DevOps. Ultimately, you have to work with the project, and you will see that whenever you create a project, you will have to associate it with one or the other organization. So when you create an account in Azure DevOps and log in using your credentials, automatically one organization is created on the basis of the name in your provided email address. So one organization is automatically created by default. So if you see here in the URL, you will see that the first part represents the organization name either in the URL, or you can also see from here that this is the organization name and it is fetched from the email ID that I use for creating an account for the Azure DevOps. So you must have at least one organization in order to work in the Azure DevOps. Another most important thing to remember is that the organization name must be unique. This is because, as you can see, that it is part of the URL. So you must have a unique organization name in order to remove the chances of any ambiguity. Now let's see how you can actually create an organization in Azure DevOps. So for that, I am going to click on this option from here, and you will see that I am now redirected to the page which shows only the organizations currently present inside my account. So right now you can see I have a single organization by this name, and which was created by default by Azure DevOps. Now in order to create a new organization, you can see this value saying new organization. Click on it, and you will be redirected to a page that looks like this. It says get starting with Azure DevOps. From here, you simply have to click on continue. Then it will ask you to provide an organization name. This part is going to be constant. You cannot change it. This part is going to be changed. So you can give any name to your organization. I'm going to call it sample organization. Okay, so it is saying that sample organization is already taken. So let me say sample organization 1. Okay. So after that, you have to select a region where your project will be hosted. Basically, you have to select the region that is closest to you. So I'm going to select South India, which is nearest to me, and it is saying that this organization name is also taken. So let me change it to sample organ 1. Now, okay, it is not saying that it is already taken. So this is a unique organization name. Then you have to enter the characters. Once this is done, click on continue. So once you click on continue, it will take some time for processing in order to create an organization. So I'm gonna come back once the organization is created. Okay, so you can see that it has finished processing, and now our organization is created. In the left navigation menu, you can see that now instead of one organization, I have 2 organizations. And this is the one that was created by default when I created my DevOps account for the first time. And this is the one that I have just created. So you can see that the one highlighted is the one that I'm currently working in, which is sample organization 1. So once you have the organization, now you can create different projects inside it and start working. But we'll see all about creating the project in the next video. Now, if you want to see different options related to the organization, you can simply click on organization settings from here. Once you click on it, you will see that in the left navigation menu, you have a lot of options for the organization settings, and the first one is the overview. From the overview, you can actually change the information about your organization. So the first thing is you can change the name of your organization from here. Then you can provide a privacy URL. Then you can provide a description. So Since you have many teams working on different projects in your workspace, so it is advised to give a suitable description to your organization so that all the different team members can actually see that which organization is for which purpose, and then they can use it efficiently. Then the next thing is the time zone. So by default, it is UTC, which is a universal time zone, but you can change any time zone if you want. Then you can see that you do not have the option to edit the region. This was selected while you created the organization. So once all of this is done, let's add a sample description to the organization. So once this is done, now simply click on save and all the new changes will be saved for the organization. Then under the overview, you can see the projects. If you click on it, you will see that right now it is empty because we do not have any project inside our sample organization which we have just created. But if you go back to your organizations, and if I click on the one that was created by default, and from here I click on organization setting, and then in the organization settings, if I click on projects from here, you will see that it will have a single project which was also created by default. Now let's go back to the sample organization. So right now there is no project in the sample organization, but we'll create some in the next video. Then you have the users. So the users are actually all the members which are currently present inside your organizations. So right now I have a single user and its access level is basic. This is because I have created this organization using this email ID. So that is why it has a single user. Then you have the billing option. If you click on it, you will see that it has all the information related to the billing of your Azure DevOps account. And you can see that for the 5 basic users, the boards, repos and test plans are free. So if you have an organization having only 5 users, then you do not have to pay anything to the Azure DevOps. But if you have more than 5 members, then you will have to pay to Azure DevOps for its services. And then you can see that for the pipelines of the private projects, the MS hosted CI/CD is 1800 minutes free. But if you exceed this time duration, then you will have to pay to Azure DevOps. Similarly, there are other information as well. Then you have the global notifications. And you also have the Azure Active Directory. So the Azure Active Directory is actually used to manage your users or the team members in your organization. So you can also read it from here. Connect your organization to Azure Active Directory. This section maps existing Azure DevOps users in this organization to their corresponding identities in Azure AD. No content or history will be deleted. So this means that Azure Active Directory is actually used to manage the users in the organization. And you have many other options as well, like policies, permissions, boards, pipelines, artifacts, repositories, etc. We are going to see the details of each of them later on in this course. But that's all about creating an organization and managing it in Azure DevOps. In the next video, I'm going to show you how you can create and manage projects in an organization. But that's all for this video. I'll see you in the next one. Welcome back. In this video, we are going to see what is a project in DevOps and what are the main features of project in Azure DevOps. Before moving towards how you can actually create a project in Azure DevOps, let's first see what is a project in Azure DevOps. So a project is a place where the actual complete product development is done by the team. So everything which is required for the development of the software or the product is available in the project. So also the project provides a repository for the source code where the team members can place the source code of the product, and a place for a group of people to plan, track progress and collaborate on building the software solution. And as I have already discussed that planning, tracking and collaboration are the most important steps in the software development. So all of these features are present inside the project in DevOps. So if we talk about the hierarchy, on the very top we have the organization, as I have discussed in the previous section, and inside this organization we have different projects, and inside these projects you can add different team members and all the main services provided by Azure DevOps, which are the boards, repositories, artifacts, test plans and pipelines. So all of these are present inside the plan. Just like an organization is by default created when we first log in into the Azure DevOps. Similarly, our team is automatically created inside a project whenever we create a new project, and the name of the team is the same as the name of the project. In Azure DevOps, there are two types of projects, the private projects and the public projects. You can have both the private and the public projects. It is nothing but the visibility or the accessibility of a project. Let's talk about both of them in detail. So the first one is the public project. If we create a public project, then public projects are visible to everyone and anyone can easily see and access all the contents present inside the public project. Moreover, no login is required to get access to the public project, and each public project has a unique URL. Public projects are mostly used for open source project development so that the source code may be available to everyone without any restrictions. Public projects provide support to share code with others and to support continuous integration or continuous deployment of open source software. Moreover, we can create unlimited number of public projects under one or more organization. Now let's talk about the private project. If we create a private project, then private projects are visible to limited users and they require that you add and manage user access. Users must sign in to gain access to a project even if it's read-only access. Each private project has a unique URL just like the public projects, and private projects are mostly used for non-public software development. So you can use the private projects for critical projects that you don't want to share openly with everyone. So that's all for this video. In the next video, I'm going to show you how you can actually create and manage projects in Azure DevOps. Thank you. Welcome back. In this video, I'm going to show you how you can actually create and manage projects in Azure DevOps. In the previous video, we have discussed everything about the project, what is a project, how to use a project, and what are the different types of projects. Now in this video, we are going to see how you can actually create and manage projects in Azure DevOps. So as you can see that I have already logged into my Azure DevOps account and I am in the home page of my portal. After logging into your Azure DevOps account, you will see all the organizations present on the left hand side. So the first thing is to select the appropriate organization inside which you want to create a project. So let's say I want to create this new project inside my sample organization. So I'm going to select it. Right now this organization does not have any project. So I'm going to create a new project. So whenever you are going to click on any of the organization name, this form will appear on your screen to create a project to get started. Or if your organization already has any project, like if I click on this one, then you will see all the available project will be displayed to you on the screen. So in this default organization, I had this already created project. But now I want to create a new project inside my sample organization. So right now there is no project inside it. So it is asking me to create a project here. So now let's go ahead and create a new project inside my sample organization. So the first thing that you have to provide is the project name. So I'm going to call it School Management System. Okay, then you have to provide a description. So I'm going to say Management System for the XYZ school. This description is very important because you might be creating school management system for multiple schools at once, so the description might differentiate between different projects. After that, you have to select the visibility of the project, which in fact is the type of the project. So as discussed earlier, there are two types of projects, a public project or the private project. So you can choose any of the one according to your requirement. But right now I'm going to click a public project. So right now it is saying that public projects are disabled for your organization. You can turn on public visibility with organization policies. Let's click on it. And you can see that here in the security policies, the allow public projects is off. So I'm going to turn it on and click on save. Now let's go back to my organization, fill all these fields. And now you can see that we can select the public visibility as well. Once you click on it, you will see by creating this project, you agree to the Azure DevOps Code of Conduct. This means that everything will be available to everyone. And once you select it, you will see that you have another drop-down menu saying Advanced. If you click on it, under it you have two options. The first one is the version control. And if we see what is present inside the version control, right now we have two options. One is Git and the second one is the Team Foundation version control. So whenever you are working with the source code, then in order to manage your code, you have two options available. Either you can manage your code inside a Git repository or use the Team Foundation version control. So let's say I'm gonna go with the GitHub, and then the next option is work item process. If you drop it down, you have four options. First one is Agile, then we have Basic, then CMMI, and the fourth one is Scrum. So these work item processes actually decide how your board inside the project will look like. So right now I'm gonna go with the basic one. We are going to discuss all of these work item process one by one later on in this course, but right now I'm gonna stick with the basic one. Once this is done, simply click on create project, and after a while you will see that your project will be created with the name School Management System. So here you go, our project is created, but right now it is empty because we have not added anything inside it. Here on the left hand side, you can see all of the main services for this project. First we have the overview, then we have summary, then there is the dashboard. We have boards, repositories, pipelines, test plans, and artifacts. All these services or all these features are very important because using them you will manage your project. Let's see each of these one by one. So if I click on boards, since right now my project is empty, so there will be nothing inside each of the services, but once you click on the boards, here is a page that is going to display all the work items. You can see the boards, backlogs, sprints, queries, everything related to your software development will be present here inside the boards. Okay, then if we scroll down, we have the repos. So as mentioned earlier, repos represent repositories, so you can connect your source code with any repository that you want. And here you have to actually provide the path of the repository where you want to store your code in order to enable version control. And then you have different options for commits, pushes, branches, tags, pull requests, etc. Then if you click on pipelines, you will see that we have nothing in the pipelines. But if you click on it, you can see that we have two options. First one is the environment and the second one is the library. So we are going to see both of them once we reach the pipeline section inside this course. Then we have the test plans. So this is the part of the project where you are actually going to test your product or the software that you have created. So this is the testing part for it. And then we have the artifacts. Right now there will be nothing inside the artifact because our project is empty. But you can add any artifact related to your product like software requirement specification document or any other document which is required for the product development or the software development can be placed inside the artifact. Now let's see what settings are available for the project. So in order to manage the project settings, you have to see on the bottom left corner of the screen saying project settings. If you click on it, you will be landed to the project settings page. Here in the project details, you can edit the information about your project. You can change the name of your project, you can change the description, and then you can see that the process or the work item process where we have the Agile, Scrum, CMMI and Basic is logged. This means that we cannot change the process once the project is created. So you have to be very vigilant when you are actually selecting the work process item for your project because you cannot change it later on. Then we have the visibility, and you can see that you can change the project visibility from here as well. Then if you scroll down, you have the project administrator. You can have single administrator or you can add multiple administrators by clicking the add administrator buttons. Then we have the Azure DevOps services, and here you can either allow or disallow all the services for the project. And then you have the option to delete a project. So if sometimes you have created the project but somehow the client refused to give your project, or in some other case you created a project but the configuration was wrong, so in those scenarios you might want to delete the project. So here you will simply have to click on this delete button and your project will be deleted from the organization. Then if I click on the next option, which is the teams, you will see that we have a single team. As I have mentioned in the previous video, that whenever you create a new project, a team by the same name is already created. And you can see that right now there is a single member, which is me, as I have not added any other members inside the team. You can create new team from this button as well. and you can click on this team and then manage it as well. Then the next option is permissions. You can see that here are a bunch of permissions related to your project. Here you can manage the access of each of the user. You can define the role and the access rights of each of the user inside the project. Then we have the notifications. You can generate notifications for different team members from here. And then you have the service hooks, you have the dashboards. From here, you can either create dashboards, add a dashboard or delete dashboard, which is going to show you the actual project progress. Then in the boards, we have the project configuration, team configuration, GitHub connection, etc. So once we connect our project with the GitHub, then we'll have the connections here. After that, we have things related to the pipelines, repositories, artifacts, and test plans. So these are the things which are present inside the project settings, and you can set these values for each particular project. So this is how you can create and manage a project in Azure DevOps. That's all for this video. I'll see you in the next one. Welcome back. In this video, we are going to see what are boards in Azure DevOps. So Azure board is one of the main service of Azure DevOps, which is used in a project to track the work with Kanban board, the work with the backlog, team dashboard, and reporting. In other words, we can say that Azure boards are DevOps interface of service that allows the teams to manage projects throughout the development lifecycle. It enables the team to keep track of their tasks, work status, user stories, backlogs, features, and any problem or flaws discovered during the projects. Epics, issues, and tasks are the three primary work items of the Azure board. Whenever you will be working on a project in Azure DevOps, then you will need an Azure board. And inside the Azure board, you can create and manage a Kanban board. So what is a Kanban board? A Kanban board is something which contains the details of all the work items that you are going to deliver or work on in a particular project. Moreover, the Azure boards are fully compatible with the Scrum methodology. Now let's talk about some of the uses of Azure boards. So the Azure boards are useful in managing and tracking your work. If you are working in a team on the same location or on the distributed team, then managing the task of the team is something very tedious. If you are working with the edge or board, then managing and tracking that task is very easy because boards provide you a clear picture of the work done or the work which is being done by each team member. So you can track the progress of each member, you can track the progress of your sprint, you can track the progress of your product development with the help of your boards. Moreover, you can also give access of board to your stakeholders, allowing to see the progress of your development as well. So if your stakeholder is interested to see the progress of the development in the sprint, then you can also add him in your project and then he can see the progress of the current sprint inside your board. Moreover, you can also manage the Scrum sprint with Azure boards. Since each organization is following the structure of the Scrum or sprint for the product development, and you can easily manage all of these things using the Azure boards. Moreover, you can also use the Azure boards to manage your product backlog. So backlog is actually the strength of your product, and managing that backlog is very easy in the Azure boards. Moreover, you can also get different types of reports using the Azure boards. It is also very important to get the reports of multiple types and loads of other things that we will learn when we will work on the boards in this course. Now let's talk about the types of boards in Azure. There are 4 types of work item processes while creating a new project. If you have seen the last video, then you will see that when we were creating a new project, in advanced section, there was a drop-down work item process and there were 4 values in that drop-down: basic, agile, scrum, and CMMI. So what is the use of that work item process? The type of board actually depends upon these work item processes. Each type provides different types of work item and workflow in Azure board. So a work item and workflow is something very important to work with different type of frameworks, and these work items and workflow depends upon the selection of the work item process. If you will choose the basic one, you will have different type of work items and workflows. If you will choose the Scrum or the Agile or the CMMI, then you will have different work items and different types of workflows. So the type of the board depends upon the selection of the work item process. So you can see that here in my simple organization, I have a project called School Management System, but I'm going to create a new project and I'm going to tell you why I'm doing so. So let's first fill out these fields. So for the project name, I am saying School Management System and I'm passing Scrum with it to show that this is the project using the Scrum methodology. Then you have to provide the description. So I'm going to write using Scrum here. Then you have to select the visibility. I am going to select the public. And then in the advanced options, version control is going to be Git, but for the work item process here, instead of basic, I am going to select Scrum because I'll be using the Scrum methodology and simply click on create. You are actually encouraged to use all of these work items in different projects to see how the board differ in interface in case of each work item. Okay, so you can see that our school management system Scrum project has been created. So right now I am inside the project in which I choose Scrum as the work item process. Now if I go inside the board and I select this drop down menu, you can see that for the Scrum work item process in the project, you can see that the work item has options of bug, epic, feature, impediment, product, backlog item, task and test case. And if I go back, and now instead of the Scrum one, I am going to choose the simple school management system where I chose basic as the work item process while creating the project. And now if I go inside the boards and see the work item, you will see that there are only 3 options: epic, issues and tasks. I am going to discuss all 3 of them in detail later on in this course. But right now I want to show you that you can see that there is a big difference between the work item options when we selected the basic work item process and the Scrum work item process. So in short, you can say that the work item process plays a very important role in your project because it decides how your board will look like and what type of work items and workflows are available to you. In the next video, we are going to see more about Azure boards. That's all for this video. I'll see you in the next one. Welcome back. In this video, we are going to see how you can set up a team for project and add members in Azure DevOps. So now you can see that we have our project created and we have our repos. But before moving towards assigning the responsibilities to the people, we must first add a team inside our project and then add different team members. So as I have mentioned earlier that whenever you create an organization, automatically a project by the same name is also created. Also, whenever you create a project, a team by the same name with added word team is also created. So if I go inside my project settings and from here I select teams, you can see that the default project team by the name School Management System Scrum team has been created. But right now there is a single member because I've created the project and so I am the member of the default project team. Now let's say if you want to add new members to the team, how can you do that? It's very simple. So I've created another account and I'm going to invite it to my team. So for that you can see this invite button here. Click on it and here you have to provide the email ID of the person that you want to add to your team. So I'm going to provide the email ID here and then I'm simply going to click on add. So you can see that added one user to one team and assigned an access level 1 to the user. Now if I go inside the project settings again and from here view the team, you will see that now there are 2 members inside the team and first one is this ID which is the admin and the second one is the user. You can either remove it or add directed members or other options as well. And once you do that, if you now go to this particular email ID that you have just added, you can see that you will receive an email for an invitation saying you have been invited to Azure DevOps. Join your organization at Azure.DevOps sample organization. Now if you click on join now, you can access all of these things which are present inside the organization. So you can view the projects and you can view everything as well. So let's say if I go inside this project, you can see that this is the project information. If I click on boards, that right now there is no board, but if I click on repositories, this was the one that we deleted. So I'm gonna go to the default repository, and these are all the things which are present inside it. So once you add a member to the team, this means that you have provided it access to all the resources of the team. So this is how you can create a team in Azure DevOps, and this is how you can add different members to the team. That's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you how you can add work item in different type of Azure boards in Azure DevOps. Okay, so now let's go ahead and move inside the project. And once you are inside the project, you have to select boards from the left navigation menu. So once you do that, you can see that if you double click on the boards, you will land on the page that looks like this. So this here is actually a board, or more specifically, it is a Kanban board. So you can see that inside the Kanban board, you have 4 different columns. The first one is for the new item. The second one is for the approved ones. Then we have the committed, and then we have done. Now, if you see the backlog items, we have features and backlog items as well. So let's say if you want to add a new item for the project, you simply have to click on this new item, and you have the option to add the product backlog item, or you have the option to add a new bug. So these are the options when we selected the work item process to be Scrum. Now if I go back to my organization, and if I select the simple project where the work item process was basic, now if I go to the boards and double click on boards, you can see that we have only 3 columns instead of 4. So first one is to do. It is going to add all the things or all the features which are not yet being worked on. And then once you started working on that feature, then it is going to be moved to the doing. And once the feature or that epic has been done, then it will be moved to the done column. So now let's say if you want to add a new item, you can add it from here. And let's say I want to call it parent login. Okay, so the feature name is going to be parent login. And here you can see that firstly we have a new item ID, and then we have the name, and its state is to do. Then if I change it to doing, it will be shifted from this column to the doing column. But right now we have created it, so let's move back to the to do column. Then you have the option to assign the task to any user. Right now it is not assigned to anyone, so let's say I want to assign it to the new user that I added to the team in the previous video. So I'm gonna provide the email ID of the user here and hit enter, and this is the member that I added to the team. So I'm going to assign the parent login feature to this user, and from here you can select it epic as well. So epics are basically a large chunks or the features of your project. So let's say if I want to add a new feature, I'm gonna say parent sign up, hit enter. You can see that new item with the ID 2 has been generated. It is in the to-do list and it is a feature, and I'm going to assign it to this user. And if you click on it, you can see that you can edit the title, you can move it to iteration, you can add an issue to it, you can add a test or delete it. So let's add an issue to this feature. So there is, let's say, no option to view password. So it is an issue with the parent sign up form that there is no option to view the password. So let's add it, hit enter, and you can see that this feature has a single issue of this one. So whenever a person is working on it, it will be in the to do part, but once the users start working on it, you can move it to doing and it will move to the do. And once you are done with it, you can move it to the done part and simply click on this check option. So you will see that now this issue is no longer available. So this is how you can add different epics and issues inside your Kanban board. But you also have another option of adding work items from here. Here you can see that we have all the work items listed here that we added from the board. You can also add all of these from here. So since we are working on the basic work item process. So we have epic issues and task only. And if I go back and choose the project in which I selected Scrum as the work item process, and now if I click on boards, you can see that once I drop down the new work item, I have bug, epic, feature, impediment, product backlog item, task and test case. So let's say if here I want to create an epic, I will select it. So firstly you have to provide a title. So let's say that I want to add student login. Okay, so I'm going to say student login is going to be the epic, or let's say student portal. It's going to be more better because epic is a set of features. So student portal is going to be the bigger task, and then we are going to divide it into subtasks or sub features. Okay, then you have the option to assign the task. I'm going to assign it to this user. Then the state of the feature or the epic is new. Then you have the reason. It is in the area school management system Scrum, and right now we have single iteration, so I'm gonna leave it as it is. If you have multiple iterations or multiple sprints, then you can select that option as well. Then you have this description for the new epic. You can either leave it as it is or fill it according to your requirements. Then you have the priority. Actually, priority is the importance of the feature. So you want the student portal to be implemented fast. So you're going to set its priority to high. Then we have the business value, time criticality and effort. You can add all of these things from here and simply click on save. So once you do that, you can see that now your epic has been created. If I go back to my workload, you can see that we have a student portal here. If I click on boards now, you can see that your epic is not being displayed here because it only shows features and backlogs. But if you go to work item from here, you can see that it is present inside the work item. Similarly, you can add either a bug to it or a feature, a task or test case or any other thing to your work item. So this is how you can add work item in your board. So that's all for this video. I'll see you in the next one. Welcome back. In this video, we are going to see what are repositories and how you can create and manage different repositories in Azure DevOps. In the previous video, you have seen that on the top of the hierarchy, we have the organization, and each organization can have multiple projects. And once you create a project in an organization, it must have boards and a set of other features inside it. And one of those features provided by Azure DevOps is the repositories. So Azure Repos is a set of version control tools that you can use to manage your code. Whether your software project is large or small, using version control as soon as possible is a good idea. So the repos or the version control systems are softwares that help you track changes you make in your code over time. So as you edit your code, you tell the version control systems to take a snapshot of your files. The version control system saves that snapshot permanently so you can recall it later if you need it. So the repos or the version control systems are very much useful when you are working in teams and a lot of people are working on the same source code or same file. So in order to manage the version control and to keep stage of the commits or the changes made to the file, the repos or the version control systems are very much useful. So now let's see how you can actually create and manage repositories in Azure DevOps. So I'm going to go into my project using the Scrum. And once I am inside the project, you can see in the left navigation menu, we have all the features which are provided by Azure DevOps for this project. So now I'm going to click on the repositories. You will land on the page that looks something like this. Here, firstly, you can see that you have an option of clone to your computer, and below it you have an HTTPS link or the URL. So this is the URL of the repository where all your code is going to be committed or pushed. So you can either go to this URL to view all the code, and you can use this URL to clone your repository in some other editor. And the other option is that you can choose from this drop down menu. There is a list of different IDs that you can select that are compatible with the GitHub, and you can easily connect your IDE with the GitHub repository to make push and pull requests and ensure version control. So you can see that we have different options like Android Studio, Data Grip, Eclipse, we have IntelliJ, PHP Storm, PyCharm, Visual Studio, Visual Studio Code, etc. So you have two options. You can select any of the one. Either you can choose this URL, copy it and then manually connect it to your IDE, or you can select any of these values and clone the repository to the IDE. Then we have another option of push an existing repository from the command line. So if you have already created repository and you only want to make a connection to that repository from the command line, then you can use this URL or this code. And then you have the option to import a repository. So once you click on the import, you have the option to select the repository type. Either you can use the Git or you can use TFVC, or in other words TFS. Then you have to provide a URL of the repository that you want to clone. And if it requires authentication, then you can check this box. If it does not require any authentication, then simply leave it unchecked and click on import. And then your repository from the GitHub will be imported. Then you have an option to initialize the main branch with a readme or the git ignore file. So the readme file contain information about your product or the project or what is going to be present inside the files of the project, and the git ignore is used to create a file that contain information about what to ignore for certain file formats or for certain IDs. So now if I say that I am using the Visual Studio IDE and I want to create a git ignore file for it. So for here I am going to search for Visual Studio and it is going to add a .git ignore file. Now once I click on initialize, you will see that it has created a readme file for me and the git ignore file for me. So here is the readme file, and if I click on git ignore file, you can see that these are all the contents which are present inside the git ignore file. And you can see that these are the specific extensions which it must ignore that are coming from the IDE. Moreover, if you scroll down a little bit, you will see the build results, and then you will have different options that you should ignore in case of different IDEs. Now, let's say if I go to the README file and I want to edit some of it. So for that, I'm click on edit here, and now I'm going to make a few changes to it. Let's say I'm gonna add link for Google, and here I'm going to say https://google.com. So once this is done, now I'm gonna click on commit, and here you can add a comment to your commit. So I'm gonna leave it to updated readme file. Then you have to provide a branch name. So right now I have a single branch name, which is the main branch, or you can also call it the master branch. And then you have option to link the work items. So right now I have no work item related to it, so I'm going to simply click on commit. And once you click on commit, it actually creates a push request and push the data into the repository. So now you can see that we have committed the following changes, and if you click on history, you will see a graph showing all the changes that are currently made. So it is going to show you that recently the readme.md file has been updated, and the person updated is also mentioned here, and it's going to give you the time and the type of commits that happened here. So now you can see that if I click on the files tab, you will have the files that have been currently added or updated. Then if you click on commits is going to show you a graph of all the recent commits and the time and the person who made the commit. And same information will be present inside the pushes tab, because whenever you commit something to your repository, it is actually pushed inside the repository. So you can see that firstly, we created a readme file and the git ignore file for the Visual Studio, and then updated the readme file. So these two pushes were committed to the repository. Then we have the next option for the branches. So right now we do not have any other branch except the main branch. From here you can manage the branches, or you can set up new branches or the new features for it. So let's say I'm going to go inside the main branch, and then from here I'm going to create a new branch inside the main branch. So let's click on new, and I'm going to call it a parent portal. So let's say we have a feature for parent portal in our main branch. So I'm going to call it parent portal. It is based on the main branch. And if you have any work items that are related to this feature. For example, you have any epic or any issue or anything that is related to this particular feature, then you can link it from here and simply click on create. So now once you do that, if you click on branches, you will see that we have a main branch and then we have a parent portal branch. And you should remember that whenever you are adding any new feature to your code, then you should not add it to the main branch, because the new feature might contain some code chunk or some part of the code that conflicts with the other part or that somehow updates the previous conditions. So you must create a new branch in order to add a new feature, and then once you are done with the feature, then you can actually merge it with your main branch and manage the conflicting issues. So you can see that this is my feature branch, and inside it I have the same two files like I have in the main branch because it was created from the main branch. So let's say if I go inside my readme.md file and I make a few changes to it. So let's say firstly I change the link to www.google.com, and the next thing that I'm going to do is I'm gonna add an h4 here, and after that I'm going to say that working on parent portal. Okay, so these are the two changes that I have made to the readme file inside the parent portal feature, and now I am going to commit all these changes, and these changes will be pushed by the branch name parent portal. You can also add the work item here, and you can add any comment to your commit. You are encouraged to add comments to each commit so that each person or the Scrum Master or other team members, whenever they see a commit, they know what is happening inside the commit. Then simply click on commit. And once you click on commit, now you can see that you have an option to create a pull request. So pull request is actually a request to merge the changes that you have made in the feature branch with the main branch. So whenever you create a pull request, your code of the feature branch is not actually merged right then with the main branch. Rather, you create a request to merge the code, and then the changes are reviewed to identify any merging conflicts. So now let's say I create a pull request. So now it is going to create a request to merge the changes made in the feature branch with the main branch. So you have a title to create a new pull request. I'm going to leave it to the updated readme. Then you have description. Then you can add different users and reviewers to view the updated changes, and they can then accept or ignore these changes. Then you can link different work items to it and click on create. So once you click on create, your pull request for this feature will be created. And once the pull request is created, you will see that right now there are no merge conflicts. This means that you are good to go and there is no merging conflicts between the changes made in the feature branch and the code present inside the main branch. So basically, a conflict arises when two separate branches have made edits to the same line in a file, or when a file has been deleted in one branch but edited in the other. Conflicts will most likely happen when working in a team environment. So in simple words, we can say that if two persons are working on the same file and the changes made in the file by one team member, but the file has been deleted by the other team member, but when they create a pull request, since one team member is still working on the file but the other one does not have the file anymore because he has already deleted it, then there is a merge conflict. And we are going to see later on in this course that how you can actually solve these merge conflicts. But right now, you need to see that there is no merge conflicts in our case. Then you have the option to approve this pull request. You can approve it with suggestion. You can wait for the author or simply reject the pull request. And if it is completed, then you can mark it as complete. Then you can mark it as draft, or you can actually abandon it. So let's say you create a pull request, but you realize that you have not completed the feature right now, or you need to change something else, then you can simply abandon the pull request and then create a new one once your feature is completed. So let's say we are in the branches, we are inside the parent portal branch, and then inside it, you add something else. For example, let's say I edit it. and add features here. Now once I commit it, I will simply click on commit here. You can see that we have committed it. Now once you do that, you can see that it has been updated. Now inside the pull request, you can see that there is single pull request and you can create new pull request from here. But if I now click on approve here, you can see that my pull request has been approved. So now if I go to the pull request and this one has been approved. So if I click on it and now once it is approved, I'm going to complete the pull request. So if I click on complete from here, you have an option to select the merge type. And if you drop it down, you have 4 different options. You don't need to worry about all of these. We are going to discuss these in detail later on in this course. But right now, we are going to select the no fast forward one. Then you have the option of post completion. Firstly, you have the option to complete associated work item after merging. So you can only merge your branch with the main branch once you think that your feature has been completed. So once your feature has been completed, this means that all the work items that were linked with that feature or the branch were also completed. So it is asking you to complete the associated work items after merging. So let's check it. And then we are going to delete the parent portal branch. So you created a separate branch for a portal, but once you are going to merge it with the main branch, then you don't need to have that feature branch separately on its own, then you can delete it. And then you have an option to customize the merge commit message. You can either check it or uncheck it and simply click on complete merge. So once you do that, it is going to show you that which person completed the pull request and there are no merge conflict. And then you also have the option to revert the pull request. So you can do that if you want to make any other changes to it and does not want to complete the pull request now. So now if I go on branches, you will see that instead of 2 branches, main and the parent portal branch, we have a single main branch. And inside it, we have merged the code of the parent portal branch. So all these work can be done inside a single repository. Now if I go back to my repos and if I want to create a new repository, then I can simply click on this option and create new repository. Here you have to provide a name to your repository. Let's say I'm going to say school management system test repository. Okay. Then you have the option to add a readme file. If you want to add a git ignore, let's say I want to add git ignore for the Visual Studio. I'm going to select it and click on create. Then you will see that instead of a single repository, now I have 2 repositories and I can work on both of them at once. And then if you want to manage any of your repository, if you want to delete any repository due to any reason, then you can simply click on your repository and click on manage repositories option from here. And once you land on this page, you have all the repositories available to you. So let's say we want to delete this new repository that I've just created. Click on these 3 dots and then simply click on delete. So it will ask you to enter the name of your repository again to confirm the deletion. Do that and simply click on delete and you will see that your repository will be deleted. So this is how you can create and manage repositories in Azure DevOps. That's all for this video. I'll see you in the next one. Welcome back. In this video, I am going to show you how you can clone an Azure repository on your local system using the command line interface. Right now, I am logged into my Azure DevOps account and you can see that right now I have 2 organizations. So I'm going to select the sample organization and inside it I have 2 projects right now. So I'm going to go inside the school management system Scrum project. And once you are inside the project, if you remember that we created repositories in the previous videos of the section. So I'm going to go inside the repositories and you can see that the repository name is School Management System Scrum and right now it has 2 files .gitignore and readme.me. So this is the repository that I am going to clone into my local system. So once you are inside this page, you simply have to click on this clone button on the right side. So once you do that, you will have an option to have an HTTPS link or the SSH link. We have to select the HTTPS and from here you have to copy this link. So once the link is copied, go back to your system and here I have created a repository called clone repo and inside it I am going to clone the Azure DevOps repository. So make sure that you have Git installed on your local system. Once you are inside the repository, I'm gonna open the command line from here. And once the command line is open, here I'm going to run the command git clone, and I'm gonna paste the URLs that I copied from the repository. So here is the repository, and this is the code that I just copied inside my command prompt to clone the repository. And once you hit enter, you will see that cloning will start, and it is a remote cloning from the Azure DevOps, and all the cloning has been done. Now, if you see that inside the clone repo, you have a new folder by the name School Management System, and if you click it, you have two files, .gitignore and .readme file. This means that you have successfully cloned your DevOps repository into your local system. So this is how you can clone an Azure repository on your local system using command line. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you how you can connect your IDE to your Azure GitHub repository and then troubleshoot all the connectivity issues. In the previous video, you saw that we cloned our Azure repository into our local system using the command line, and this is the repository having two files, the gitignore and the readme.md file. Okay, so now I am going to open it into an IDE to actually connect my project with the Git repository. So I have opened my Visual Studio, and from here I have already opened the folder once. So it is showing here, but in your case you will have nothing here. So you have to click on open a local folder, and then from here you have to navigate to the location where your repository is present, and once you click on it, you have to select the folder. Once you do that, the Visual Studio will open and is going to show you both files which are present inside your repository. But right now you will see that there is a lock behind both of them. This means that these files have not been changed since the last time we cloned these files from our repository. And also in the bottom right corner, you can see that this is the repository that is connected to our Visual Studio, and this is the GitHub repository. So now I'm going to go to File, and I'm going to create a new project. And from these options, a new empty project, and I'm going to click on Next. Here you have to provide a name to your system. So I'm going to call it School Management System, because this is what the name of our repository is. And I'm going to have a solution name. So instead of solution, okay, here I have click on Create a New Solution, and then let's change it to .app. And this is going to be the solution name, which is School Management System. Okay, place the solution and project in the same directory. You don't need to check it. Then you have to select the location, which is the most important part. So from here, you have to browse to the location where your clone repository is present. Okay, so once you do that, click on the folder and select folder from here. Then click Create. So once you do that, you can see that now you have a plus sign with your folder name. This means that your project has been created, but right now there are actually no files inside it. So let me add some source files here. So I'm going to click on Add, and from here I'm going to click on New Item, and from here I'm going to select .cpp file, and I'm going to call it main. Okay, then I'm going to click on Add. You can see that a main.cpp file has been created in the source file. Let's add some code here. So you can see that I have created a basic program to print hello world, and all this is present inside my main.cpp file. Let's quickly run this. So you can see that hello world is printed. This means that our project is running fine. Okay, so now let's go ahead and push all these files along with the project inside a Git repository. So once you go inside the Git option, from here you have fetch option, which is to fetch any changes or commits that you made to your code. Then you have the pull option. The pull is going to fetch the new code from the repository, and if there are any merging conflicts, then it is going to give you an error so that you might resolve it before actually pushing the project. And then you have the option to push. So before pushing the project, let's quickly make a pull request, so that if there are any conflicts in the code, they might be resolved. So it is pulling changes for the current branch, and it hasn't given any error. This means that there are no changes in the Azure repository that conflict with our changes in the project. So now let's go ahead and push our code into the repository, and from the Git option, click on push, and you can see that pushing main started. Your task will continue running in the background. Okay, so it is going to run in the background, and you can see that our operation is in progress. Now the Git credential manager has opened, and it is asking us to use a Microsoft account for the GitHub. So here you have to log in using the account through which you have created your Azure DevOps account. So I'm going to do the same. This is the one that I use for creating the Azure DevOps account. So I'm going to log in using this account. Then you have to provide a password for the account and click on sign in. Okay, so it has successfully accepted the credentials, and now we are pushing our code into the repository in the main branch. So it is required that you have Git Credential Manager installed when you are installing Git in your local machine. This is because if the Git Credential Manager is not present, then you will have to go inside the Visual Studio settings, and then you have to manually add the Git repository path and all the credentials. So in case of Git Credential Manager, you will simply have to log into the account that you use while creating the Azure DevOps account, and then everything will be managed. Okay, so you can see that pushing main task completed successfully. This means that our file has been successfully pushed. Now let's go back to our Azure DevOps account, and this is the project that I am currently working in. So let's reload everything, go back to the project from here, and once you are inside the project, you have to go to the repositories. So you can see that our Visual Studio files have not been pushed inside the DevOps repository. So let's see what's the issue. Go back to Visual Studio, and inside the Git tab, you have to find Manage Remotes. Okay, so you can see that this is the path of the repository where we have to make the push and pull request. So this is the path of the origin. Let me just copy it and see where it takes me. Okay, I have copied the path. Go back to my browser. I'm gonna open a new tab and place it here. Hit enter. So apparently it should take us to the repository where all of this data will be present, but it is showing us nothing. So maybe there is something wrong with the repository path. So let's copy it from here. Go back to your Visual Studio, go to Manage Remotes, and here let's edit the origin. And for the origin, I'm gonna paste this path here. And the push matches the fetch. Click Save. Now click OK. And once again, make a pull request. And since there are no issues, so now let's go ahead and make a push request. So you can see the task is continue running in the background. Okay, so it has started pushing the main and everything is up to date. Now let's go back to our Azure DevOps account and reload the page. So you can see that now we have the school management system folder here, and if you click it, you have the app and everything. If you click on app, then you have all these folders and all these files inside it. So this is how you can connect your IDE with the Git repository and troubleshoot all the connectivity issues. That's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you how you can actually build pipelines in Azure DevOps and connect your repository with the pipeline. Whenever you talk about the foundation stones of Azure DevOps, then two things must be kept in mind. First is the continuous integration, and the second one is continuous deployment. So you are going to see both of these concepts used a lot by every practitioner of Azure DevOps. So continuous integration has to do with the ability to always integrate code and have a solid foundation for your code base. And when we talk about continuous deployment, then it means that be able to continuously deploy all these code which we have just integrated without messing up the actual system. So we should be able to deploy the code, and at the same time we should be able to revert back any changes that are messing up with our system. So the goal is to make continuous integration and continuous deployment as seamless as possible. So that is why Azure DevOps have this feature which is called the pipelines. So the pipeline is going to allow you to set up the rules by which any application, once it is built, meaning compiled, and once it is run, we called it an artifact. And then the artifact, which is the compiled version of this application, can be then deployed, and then we can set up a set of rules for the deployment, like what server it will go through and what type of environment will it go through, etc. So in short, the purpose of pipelines is to automatically build and test our core project. So I'm gonna go inside my project, which is a school management Scrum system. And from here in the left navigation menu below the repositories, you can see pipelines. So click on it. And right now we do not have any pipeline, so this page will be empty. So as I have already mentioned, that pipeline is basically used to build your application or the development code. So I'm going to go inside my repository. In the previous video, I uploaded the code from my Visual Studio IDE inside the repository. So once you are inside the repository, you can see this setup build button here, and once you click on it, it will automatically redirect you to the pipelines page. So from here, you have to actually configure your pipeline. And you can see that the connect and select part has already been done, because once you are inside the repository and you click the build button from here, so it automatically connected your repository to the pipeline, and it also selected all the code that you want to pass through the pipeline. So you can see that your pipeline is not limited only to a specific technology. You have different options to select from. And you also have a show more option to have even more technologies added to your pipeline. So you can see you have Android, you have C++, with GCC, you have the Docker, you have the Gradle, you have Node.js, and a lot of other technologies to create your pipeline. Now from out of these options, I'm gonna select the C++ because it was a simple C++ file. So once you do that, it is going to automatically generate a YAML file for the pipelines, and you can see that this is all the code related to the YAML files. So the YAML file actually contains the triggers and the steps of how you can build your pipeline. So now I'm gonna go and click on save and run. It is going to show you that you have to add a commit message. So the default one is set up CI with Azure pipelines. I'm going to go with the default one. Then you have the option to commit directly to the main branch, or you create a new branch. And I already discussed why you want to create a new branch and when you don't want to create a new branch. Okay, then it is committing here because this new file has been adding to the new project, and all of these things will be updated in the Git repository as well. That is why it is not only giving us the option to save, rather it is also giving us option to commit the YAML file to the repository. Now simply click on save and run, and you will see that your pipeline will be started creating. So you can see that right now our job is in the queued state and it has started, and time elapsed is not appearing just now. So it is triggered by the system, and the title of it is Setup CI with Azure Pipelines. Okay, so you can see across by the side of your pipeline and it says failed. And if you see the error, you see it says no hosted parallelism has been purchased or granted. To request a free parallelism grant, please fill out the following form. So you have to open this form from here. So the form is going to look something like this. You have to fill out this form and then submit it, and you can see that it is going to take 2 to 3 business days to proceed the request. And in the meantime, you have to perform a few things. Go back to your DevOps account. Firstly, you have to go to your organization, and in the organization settings, go to policies, and you have to switch on your allow public projects option, because we are not doing this on the commercial purpose, so we can always allow public projects. Then you have to go inside the project in which you are working. So right now I am working on the school management system Scrum project. So I'm gonna go inside the project, and once I'm inside the project, I'm gonna go to the project settings. You have to change the visibility to public. So I've already set the visibility to public, but if you have set the visibility to private, then you need to change it to public. As you know that I filled the form for the free tier acquisition, so I got the email, and now once I refresh my page, now you can see that for the private project, you have one parallel job up to 1800 minutes per month. Okay, so this means that free tier has been granted to us. Now I'm gonna go to my pipelines, and from here I'm going to delete the previous pipeline and I'm going to create the new one on the same repository again. So in order to delete it, you have to provide the name of your pipeline, click on delete, and you will see that your pipeline is deleted. Now let's go ahead and click create a new pipeline. So I'm gonna go to the repos, and from here, firstly I'm going to delete this YAML file for the pipeline, click on commit, and you can see that now we have the setup build button. Hit on it, and now you are redirected to configure your pipeline. From here, you have to select the C++ option, just like we did previously, because we have created a C++ project. So here you can see that the trigger is main. This means that any change inside our main branch, then the pipeline will be triggered. Then inside the pool, we have the VM image to be Ubuntu latest, and I'm gonna change it to Windows 2010 because this is what I have right now. And then you have steps to make the script. Now once you are done with it, simply click on save and run. You have to commit it because the YAML file will be added inside the source code in the Git repository, and click on save and run. Once you do that, you will see that your pipeline will start creating and the job will start running. So right now it is in the queued state. So you can see that our job is running and it's showing us the results of all the steps side by side. So let's see what's the issue. So it is saying that cmd.exe exited with code 2. The error was because we selected C++ with GCC in the pipeline configuration. So I've deleted that pipeline, and now let's go ahead and create a new pipeline. And from here, let's go to repos, and it will be easier to set up the pipeline from there. So I'm gonna delete the YAML file from the repositories, and now it is gonna give me the option to set up the build. So click on set up the build. It will configure the first two steps for you. And now in the third step, where you have to configure your pipeline, you have to select ASP.NET. Okay, once you do that, it is going to give you all the options. I'm gonna go with the Windows latest VM image and nothing to change. So simply I'm going to click on save and run. So once you do that, it is going to ask you to commit it, click on save and run, and you will see that in a while your pipeline will start running. So now let's click on the job to see each step of running. So you can see that right now our job is actually in the starting state, and you can see that our job has been initialized. Then these are all the steps that will be performed in order to complete the job successfully. So you can see that our first step has been done, our second step has been done. Now it is working on third step, and it has also been done. Now it is working on the fourth one, and it is done as well. Now it is working on the fifth one and sixth one, and all of these done are as well. So once the post job step is done, this means that our job has been completed, and you can see a green tick here. So now if I go back, so you can see that there is a green tick with your pipeline, which shows that there is a success of your job. So every time we make any change in the main branch, then this pipeline will be triggered. So now let's go to our repositories, and inside the repositories file, I'm gonna go inside my readme file. I'll edit it, and I'm going to add a new line here, which is gonna say created a new pipeline. So you can make any other change in your project if you want. I'm simply going to change the readme.md file because it is very convenient. So once you do that, you have to simply click on commit to add it into the repository. Click on commit. You can see that it is committed in the main branch. And once this is done, now if we go back to the pipelines, you will see that now our pipeline is once again in the queued state because we have made a change into our main branch, which has triggered this pipeline. So if I click on this, you can see that this was the one that we executed previously, which was 2 minutes ago, and this is the one which is in the running state, which is triggered by the changes we made in the main branch just now. So this is how you can actually build pipelines in Azure DevOps. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I am going to show you how you can create release pipelines in Azure DevOps. In the previous video, you've seen how you can create build pipeline in Azure DevOps. Now, in this video, we are going to see how you can create release pipelines. So if you click on releases from the left navigation menu here, you can create release pipelines in Azure DevOps. The release pipeline will actually hook on to the build pipeline and will allow it to be deployed to an environment. So the tools in the Azure DevOps will know that this is the type of environment which is suitable for the project, and these are all the tools that will be needed to successfully deploy it to an environment. So once you click on new pipeline to create a new release pipeline, you will notice that there are a bunch of templates for it, just like we have different values for the build pipeline. So these templates allow you to select the service suitable to the type of project you are working on, or you can actually create an empty project and add your own steps. So from here, I'm going to select the empty job and then add the steps later on. So once this is done, now the next thing is to add an artifact. So what is an artifact? An artifact is actually the compiled code of our application. So from here, you have to define actually where your build is present. So it is present inside our school management system Scrum project. So you have to select it, and then for the second part you have to provide the source, which is actually your build pipeline, because it is actually building your project. So here you have to select your build pipeline name. So this means that every time you complete a build, you are supposed to release an artifact, and then that build is further used in the release pipeline. So once you do that, if you see that no version is available for school management system Scrum, or the latest version has no artifacts to publish, okay, no problem. So this means that I have to go back to the pipeline and make sure that it is producing an artifact. So I'm going to leave this page and go back inside my pipelines, and then you have to edit this pipeline. So click on these three dots and click on edit, and once you are redirected to the YAML file, you have to see that actually where your build is being released. So you can see that we are actually simply building the platform. So we have missed the part of actually creating the artifact. So here I am going to paste these lines in which I am actually publishing the pipeline artifact, and the target path is pipeline workspace. The artifact is going to be schoolmanagement.app, and then the publish location is going to be pipeline. So another way of writing this is, if you are not familiar with the YAML file notations, then you can see here on the right side that you have tasks. Since we want to create a task for the publish pipeline artifact, so you have to type here publish pipeline, and once you do that, you will see that we have the publish pipeline artifact, and once you click on it, it is going to generate something like this. So now you simply have to save this pipeline and click on save, and then you are going to rerun your pipeline, and in turn it is going to create a pipeline artifact for us, and then we can use it inside our release pipeline. So you can see that I have redone my pipeline, and now it has successfully executed. Now let's go back to the releases, and I'm going to click on new pipeline. For the template, I'm going to leave it empty, then I'm going to add an artifact. So for the project, I'm going to select School Management System Scrum. Then for the build pipeline, I am going to choose my build pipeline. And once you select it, now if you scroll down, you can see that the artifacts published by each version will be available for deployment in the release pipelines. The latest successful build of School Management System is published the following artifact. So this is the artifact that is published as a result of our build pipeline execution. Now I'm going to click on add. So you can see that the artifact has been added here. Then we have the option for the schedule. So the schedule is actually used to schedule the time where you want to release the trigger. So by default it is disabled, but if you enable it, you can see that you have days of the week here, and you have the time which you can set. Then on same time each day your release pipeline will be triggered, even though there may or may not be any changes inside the application. So you can play around with all of these settings if you want to add a scheduled release trigger, but I am going to leave it to disabled. Then you need to add the stages. So you have different options to add the stage. Either you can create an empty job, or you have the option to add your app service deployment, or you can use IIS website or any other. And it is not necessary that you use only a single stage. There might be multiple stages related to a single artifact. So let's say that I have right now one stage, but if I want to add a pipeline of the stages, then I can simply click on add new stage, and for that I can select a different service for here. And similarly, you can create the pipeline effect for your stages, and you can see that for each stage you have jobs and the task. For the stage 1, if you click on it, you can see that there is only one task, which is to deploy the Azure app service. Now if I go back and if I click on stage 3, you can see that it have one job and two tasks. So there are deploy what to Azure app service, and the other one is deploy jar find to the Azure app service. So you can add any Azure subscription if you have. So right now I'm working on the free tier, so I do not have any Azure subscription. But if you are actually working in the development environment, then you need to add your Azure subscription here. You have to provide an application name, and then you can simply go ahead and release your pipelines. Then if you want to delete it, simply click on any stage and click on delete button. It is going to delete that stage for us. Okay, simply click on this one and click on delete. Now if you want to add multiple artifacts, you can click add button from here and add different artifacts, but right now I have only a single artifact. And let's say that if you want to add any other stage template, let's say you want to create an IIS website, you can simply click on it and click on apply, and it will be added to your application. So for IIS website, it has 2 jobs and 3 tasks. So it has IIS web app management, web app deploy, and then we have the SQL DB deploy and SQL deployment. So you can give a name to your website. So I can say school management website, and then simply you can see other options here. You can create an application pool name or all other things that you require. Then you can see that for the IIS deployment, you need to have a deployment group. So I'm gonna right click on deployment group from the left navigation menu and open it in a new tab. Now from here you have to click on add a deployment group. You can give any name to it. I'm gonna say school management app -dev. Okay, and then simply click on create. And you can see then you have the option to select the type of target to register. I'm working on Windows, so I'm going to click on it. And then you have the registration power script, which you can copy and use it for later purpose. Once you have created the deployment group, now you have to go back to your pipeline, and from here you can select the deployment group that you have just created. School management app dev, and then all of this is configured. Then you have to see IIS web app manage. Here if there is anything needed, then you can add it. You can add task versions or all other things. Then you have the SQL deployment. For that you also have to select the deployment group, and this seems fine. And then for the IIS web app manage, you have to enable IIS, and this seems fine. Then once this is done, simply click on save. And once you save it, now if you click on releases, you can see that this is your new release pipeline, and you can simply run it using the create release option. So right now I do not have the required resources to create the release pipeline, so I'm going to leave it. But you can always set up the environment and all the resources and can run it on your own. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you different ways of how you can set up a repository in Azure DevOps. As we have already discussed that in Azure DevOps, there are 2 source management control systems integrated in it. And the first one of them is the GitHub, and the other one is the TFVC, which is Team Foundation Version Control System. So you can use either one of them, or you can use both of them running in the same repository. In this course, we are going to have a look at both of these. So I'm going to go inside my school management system Scrum project, And if I go inside the repositories, you can see that right now I only have one repository which is of the type Git, and you can see it from the symbol here. And the code that we are going to use in order to place inside our Git repository is ASP.NET Core application. And one of the main feature of Azure DevOps is that it is not dependent on any framework. It works perfectly fine in all different frameworks: ASP, Java, Android, Python, Node, JavaScript, or JavaScript frameworks. Everything is supported by Azure DevOps. So now in this chapter, I am going to create a new GitHub repository, and inside it, I am going to place my code, which is going to be ASP.NET Core Framework project. And along with it, I am going to use the Visual Studio as my IDE. So in short, we can say that Azure DevOps supports all the framework placed inside the repository, and all those IDEs that have Git functionality embedded in them are compatible with Azure DevOps. So now we are going to see how you can actually create a new Git repository in Azure DevOps. I've already discussed it in the previous sections, but let's quickly go through it. So you remember that in the top of hierarchy, we have the organization, and once you create an organization, a default project by the same name is also created. And once you create a project, then inside the project, you have certain DevOps features like boards, repos, pipelines, test plans, and artifacts. And inside the repos, you can have multiple repositories at once. So in order to create a new repository, you are going to go inside this school management system scrub, and from here you have to click on this plus button that says new repository. So once you do that, a dialog box will appear that says create a repository. So the first option is a drop down menu. From here you have to select the repository type. Either you can select Git or you can use TFVC. So I'm gonna go with Git here, and then you have to provide a repository name. So I am going to call it SCM_test repo. Then you can either uncheck the readme box. I am going to check it. Then you have to add a git ignore file. Since I am going to be working with the Visual Studio IDE, so I am going to be adding the Visual Studio.gitignore file in the main branch. And you can see that your repository will be initialized with a main branch. Once all of this is done, simply click on create. And you can see that your repository creation was in progress. And now your repository is created. And inside it, we have a gitignore file and a readme file. So you can see that a repository is created. If you click on this drop down, you will see that now instead of one repository, we have two different repositories here. And then you have an option to manage the repositories. Once you click on it, you will have all these options related to the repositories that you can manage. Also, if you click on it, you can see that we have an option of import repository, and it is actually going to import a repository from the GitHub into your Azure DevOps repos. So let me show you an example. In the repository type, you have to select Git, and then you have to provide a URL to clone the repository. So I'm going to clone this GitHub repository inside my Azure DevOps repos. So I'm going to copy its URL. I'm going to come back and paste the URL here. Since it does not require authentication, so I'm going to leave this box unchecked and simply click on import. You can see that your import has started and it is on its way. So once the request is processing, I'm going to pause the video and I'm going to come back once the cloning is done. Okay, so you can see that now we have 3 repositories, and the first one is the classified Netcore identity security repository. Inside it, we have these folders and all the files which are imported from the GitHub repository. So this scenario is useful if you have previously uploaded your code inside the Git repository, but you now want to upload your data inside the Azure DevOps because it is more convenient to use, or you want all your team members to equally see and collaborate on the code. Then you can use this import repository option to import all your code from GitHub repository into the Azure DevOps repos. So now we have covered how you can create a new repository inside your Azure DevOps and include a readme file and a gitignore file. And I've also shown you how you can actually import a repository from the GitHub. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you how you can perform different Git operations in Azure DevOps. As I have already discussed that there are 4 main Git operations: clone, fetch, push and pull. Clone is actually used to make a local copy of your repository on the local system. Fetch is used to get any updated files from your remote repository into the local repository. Pull is used to pull out all the files from the remote repository into the Git repository in order to have any updated files. And then the push is used to push the files from the local repository into the remote repositories. So now let's quickly see all of these through an example. So here, if you remember that in the previous video, I created this SCM test repository inside which I have a readme file and a git ignore file. So I'm going to clone it inside my local system. So to do so, you can click on this clone button on the right side and you have two options. You have a URL for the command line, and if you want to clone the repository using the command line interface, then you can use the git clone command and pass this URL and your repository will be copied or cloned. And the other option is that if you are working with an IDE, then if you click this drop down menu, you have different IDs available which you can use to clone your repository. Since I am working on Visual Studio, so I'm gonna go to the Visual Studio and select it from here. And once you do that, it is going to ask you that open the Microsoft Visual Studio Web Protocol Handler Selector. So I'm gonna click on it. And once you do that, you will see that your Visual Studio will start opening. And once your Visual Studio is opened, you will see that you have a dialog box from the Azure DevOps that says clone from Scroll Management System Scrum SCM test repository. The remote path is this one and this is the local path. So you can change the local path where you want to save your project. So I'm gonna go inside my D drive and I'm going to create it here. I've created a new folder inside it. Let's rename it to SCM test repo. Okay, so once this is done, I'm gonna select it and click OK. So now you can see that this is my local path, and once you click on clone, you will see that your cloning from the remote repository into the local repository will start. So you can see that our repository is cloning. Okay, so you can see that our repository has been successfully cloned, and now we have two files which are the git ignore and the readme files from our remote repository. And you can see this little log sign from here. This means that no changes have been made to these files since it was last cloned. So now I'm gonna make a few changes inside it. Let's right click it and I'm gonna add a new file inside it. And out of these all file formats, I'm gonna create a new HTML page. So you can see that this is the auto-generated code inside the HTML page. And let's say inside my body, I'm gonna add a new h1 tag, and here I'm gonna write hello world. Okay, so in the code that I cloned from the remote repository, I have added a new HTML page, and also inside the page I have added a new h1 tag. So you can see that there isn't a log symbol by the side of this HTML page. This is because this is the file that was not cloned from the remote repository and it needs to be pushed inside the remote repository. Here are all the options that you can do for this file. So firstly, if you remember that we created a local copy of our repository, so whenever we make any changes, then that changes first need to be committed to our local repository, and then all those changes should be pushed inside the remote repository as well. So let's first quickly commit all of the changes inside our local repository. So I'm gonna call the commit as added in HTML file. Okay, now I'm simply going to commit all of these changes inside my local repository. So once it's done, you can see that the commit has been created locally. Now, once the commit is created, now if you click on this Git option from the top toolbar, you can see that you have different options: fetch, pull, push and sync. So fetch is used to get the files that have been changed in the remote repository but they are not present inside the local repository. So if I click on fetch, you can see that fetching from origin started and the task is running in the background. So if I click on it, you can see that fetch is initiating and the task completed successfully. This is because there was no file in the remote repository that we have changed and is not present inside our local repository. Then the next option is to pull the changes. So fetch is only going to pull all those files from the remote repository that have been changed and are not present inside the local repository. But pull is going to pull all the files from the remote repository inside the local repository. And in order to push the changes that you have made to your local repository, you can actually use the push command, and it is going to push these files inside your remote repository. So this cloning and all these operations are pretty much useful, that you created a main repository and all the team members working on the project may create a clone of that repository on your local system, and then they make changes according to the task allocated to them. And once they are done with the task, they can actually create a pull request to pull any changes, because if two persons have made changes to the same file without actually pulling the changes, then it may result in merging conflict, which I am going to discuss in the next video. So you have to make sure to either fetch or pull the changes before pushing your data inside the main repository. So I have already fetched the data and there is nothing that is updated inside the remote repository. So now after committing my changes in the local repository, I am simply going to push it to the remote repository inside my Azure DevOps. So you can see that pushing main has started and it is running in the background. So you can see that the task completed successfully. Now if you go back to your Azure DevOps account and inside my repository, if I reload the page, you can see that now in addition to the readme and git ignore, we also have the HTML page here. And if you click on it, you can also see the contents of the HTML file. Now let's see that I want to edit it from here. So I'm gonna add in h2 tag, and here I am going to pass updated, and I'm going to close the h2 tag. Okay, so once this is done, you have to commit the changes in order to add it to the repository. So the changes have been committed. Now let's go back to the Visual Studio, and if I click on Git from here, we go ahead and make a pull request to pull the changes for the current branch. So it is pulling the changes, and you can see that once the pull request is completed, now we have an additional h2 tag with the h1 tag, and this is the tag that I added from my remote repository. So once you make a pull request, all the changes from the remote repository are pulled inside your local repository. So this is how you can perform different operations on the Git repository. That's all for this video. I'll see you in the next one. Welcome back. In this video, I am going to show you what are merge conflicts in Azure DevOps and how you can deal with those merge conflicts. So in this video, I'm going to actually simulate a merge conflict, and I'm going to show you how you can actually solve or deal with the merge conflict. So a merge conflict usually occurs when two persons or two sources try to modify the same file without actually pulling the changes of the previous person. So let's say that if a person working on its local repository or the local copy of the repository makes any changes in this line 10, and then the other team member also made some changes into the line 10 of this file on his local copy of the repository, and then he merged those changes inside the main repository on the remote side, and the other person will try to push his code inside the repository. It is going to raise a merging conflict because both team members have made the changes to the same line in the same file. So it will ask us that if you want to change either one of them or if you want to keep both of them, then you have to manage the conflict in some way. So let's say I'm editing this file from the remote repository, and here I'm adding another h2 tag, and I'm going to say merge conflict simulation because this is what I'm going to do in this video. So I'm going to say merge conflict simulation. I'm going to close the h2 tag, and I'm going to commit the changes. So once this is done, I'm going to go back to my Visual Studio, and I'm going to do similar thing here. Here I'm going to make changes in the file. I'm going to add an h2 and write a line caused merge conflict. So inside my local repository and inside my remote repository, I have made changes to the same file, and you can see that here is a tick beside it. This means that it needs to be committed and pushed to the repository. So now I've made changes to my local file and I'm going to go to the Git, and from here I am going to commit my changes inside my local copy of the repository. So for the commit, I am going to call it updated HTML file, and I am going to commit all of the changes. So you can see that a commit has been created locally. Now if I go ahead, click on Git, and then from here I am going to select sync, which is pull then push command, and you will see that pulling the current branch. And now it has thrown me an error saying the pull completed with conflicts in the SCM test repository. Okay, so now let's see what are actually the conflicts. So file contains merge conflicts. If I see the merge editor, it has shown me that these two files are causing a merge conflict. So here inside the Visual Studio, you can see side-by-side visualization of what is actually causing the conflict. So it has highlighted the line and the actual words which are causing the conflict. So you have different scenarios. Either you can accept the incoming changes and get rid of the local changes, or you can keep the local changes and get rid of the incoming changes, or you have an option to select both of these and merge both of them inside the outcome. So if you check both of these, then the two changes will be merged inside the file and the new commit will be sent to your remote repository in the Azure DevOps. So once you do that, you simply have to click on accept merge. And once you do that, it is going to show you a new file where you can see that now instead of simply one line after updated, we have now two H2 lines. First one is the merge conflict simulation and the second one is the caused merge conflict. Now once this is done, you simply have to go and commit your changes inside your local repository. So I am going to say conflict resolved. Because the conflict is resolved, I am going to commit the stage. So the commit is created locally. Now I am going to go ahead and create a pull then push request. So you can see that it is pulling the current branch, and now pulling is done. Now it is actually pushing the current branch. Okay, so you can see that now there is no merge conflict. Now if I go back to my Azure DevOps and if I reload the page from here, you can see that the changes that we made in the Visual Studio are also being reflected here. Here, instead of just merge conflict simulation, we also have an H2 tag saying the cause merge conflict. So you can see that this is how you can deal with the merge conflict on the basis of different scenarios. So that's all for this video. I'll see you in the next one. Welcome back. In this video, we will discuss what are branches in a repository and how you can actually create and manage branches inside a repository. Branching is a strategy that software development teams adopt when writing, merging, and deploying code when using a version control system. Basically, the branches are primarily used as a means for teams to develop features, giving them a separate workspace for their code. So each developer gets their own copy of the code and they can create different branches inside the code to add their features. These branches are usually merged back to a master branch upon completion of the work. In this way, different features are kept apart from each other, allowing you to fix mistakes more easily. In simple words, we can say that branches protect the main line of code and any changes made to any given branch don't affect other developers until and unless you merge your branch code inside the main branch. So up till now, we were only working with a single branch, which was the main branch or the master branch. But whenever you want to add any new feature, then you will have to create a new branch other than the main branch and start working on your feature on the feature branch. But once you are done with your work, you can check for any errors or bugs and then you can merge your feature branch with the main branch. And then when any other team member or the developer will pull the data from the main branch, then your work, which was merged inside the main branch, will also be fetched by him. So now let's quickly see how you can actually create branches in a repository. So you can see that right now I have this HTML page and these are the lines that are present inside the code. So you can use any other code file that you want. I am working on the one that we used previously. So you can see here that we are working in the main branch. You can see that this is the symbol of the branch. and you can see that beside it we have the main branch. So whenever you want to add any new feature to your application or to your code, you have to create a new branch. So in order to create a new branch, once you click on it, you can see the new branch button here. Click it and you will see a dialog box appearing. Firstly, you have to provide a feature name. I'm going to say new feature -1. It is saying invalid character. Let's make all of these in small letters. And okay, so it was causing the error because of the space. So you should keep in mind that the branch name does not contain any space. And then you have to select a branch name on the basis of which your new branch will base on. So right now I only have the main branch, so it is going to base on the main branch. And then you have the option to check out the branch, then simply click on create. Once you do that, you can see that your branch is created and we are automatically switched to the new branch, which is the new feature 1 branch. And you can also see it from here that now we are in the new feature 1 branch. And all the changes that we are going to made in this file or add any other file, then all of these will be the part of the feature branch and will not be reflected in the main branch. Okay, so let's say that right now these were the lines of code that was in the main branch, but now I'm going to add a new code lines inside this file. So let's say I'm writing a new p tag inside which we have the text, this is Azure DevOps course for beginners. So this is going to be inside a new feature 1 branch, and let's say I'm adding another heading here which is the h3 tag, and I'm going to say new feature 1 started. And it is going to make some differences in the code between the main branch and the feature branch. So once it's done, now quickly save your project. And you can see that now this HTML page has a red tick beside it. This means that there are certain changes which haven't been committed. So now let's go ahead, click on Git. And from here, you have to click on commit or stash. Click on this and you will see a new dialog box appearing. Let me bring it here. Okay, so you can see that it is asking us to enter a message. So I'm going to say commit for new feature branch. And after that, you can see that here you have the option to make the commit. Since we are working in the new feature 1 branch, so it has by default selected that branch. And once you have given a suitable title for your commit, simply click on commit all, and all the changes will be committed to the new feature 1 branch. Let me show you an interesting thing. So these are all the things which are present inside the new feature 1 branch. But if I select the main branch from here, you will see that those new lines of code have disappeared from the HTML file. And once I switch back to my new feature 1 branch, you can see that the files have appeared. And these changes will not be reflected in the main branch until and unless you merge the code inside your feature branch with the main branch. So let's say I move inside my main branch, and in order to remove any merging conflict, I am going to leave these lines, and here I am going to add a new p tag in which I'll say inside the main branch. And once this is done, go back to your commit and stash, and here I am going to say commit after branching to see that this is the commit that we did in the main branch after branching. And once this is done, click on commit all and save it, and you can see that your commit has been created locally. Now let's quickly go ahead and see the history. Click on Git, and here you will see that you have the option to view the branch history, or let's say I want to manage the branches. Click on it, and you can see that we have a graph showing all the commits and the branches. So you can see that this is the graph for the main feature where we have the conflict resolved, and then we have the commit after branching. But once we click on new feature, you will see that we have the commit resolved, and then we have the commit for the new feature branch, and there are no incoming changes. So up till this point, which is the conflict resolved, we have same commits for both the main branch and the new feature 1 branch. But after that, we are moving towards different paths. So in the next video, I'm going to show you how you can actually merge these branches and rebase them. But that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you how you can perform merge and rebase operations on your repository. In the previous video, we left off at this point where we created a new feature branch and added some new code inside it, and then we saw that the changes made in the new feature branch were not reflected in the main branch, and this was the graph showing our branching history. So now let's go ahead and see how you can actually merge your feature branch with the main branch. There are a number of ways of doing so. So if you click on this branch name from here, you can see that these are the two branches that are available to you since we want to merge this new feature branch into the main branch. So you have to right click on the new feature, and you can see that here you have two options. First is to merge into the current branch, and the second one is to rebase the current branch onto. So let's see what is the difference between the two of them. So the merging allows the developers to merge the Git branches while the logs of commits on branches remain intact. So this means when you will merge the new feature branch into the main branch and you see the merging history or the branch history, you will see all the commits made in the feature branch even after it is merged in the main branch. This is because we have used the merge operation to merge the feature branch into the main branch, and all of the commits made into the feature branch before merging into the main branch will also be seen. On the other hand, we have the rebase operation. So the git rebase is a command that lets users integrate changes from one branch to another, and the logs are modified once the action is complete. Git rebase was developed to overcome merging shortcomings specifically regarding the logs. So this means that when we use the rebase operation to merge the feature branch into the main branch, then all the logs and all the commits that we made inside the feature branch before merging it into the main branch will not be shown inside the history. So firstly, I am going to show you what happens when you use the merge operation to merge the feature branch into the main branch, and then I'll create a new feature, and then I'm going to show how the rebase operation works. So for this feature branch, I am going to select merge into the current branch. Select it, and it is ask you, are you sure you want to merge the new feature into the main? Click on yes, and you will see that the merge completed and committed. And now you can see that this is the graph showing our branch history. So you can see that once the conflict was resolved, after that we were having two new paths. The first path was commit for new feature branch, and the second one was commit after branching, and both of these paths combined on a single one which says merge the branch new feature one. So this means that all the logs or all the commits that we made inside the new feature one branch before merging it into the main branch were being seen in this graph. So now I am going to show you how the rebase operation works. So for that, I am going to go ahead and delete my new feature one branch to show you clearly how the rebase operation will work. So you can see that it has been deleted, and if I refresh it now, you can see that this was the commit, but right now we do not have any other feature branch. So I'm going to go back and create a new branch, and this time I am going to call it new feature 2. It is going to base on the main branch, and click on create. So you can see that now we have a main branch and a new feature 2 branch. So now let me go back to the main branch and make a few changes inside the code. So this is the code inside the main branch. So I'm gonna add a new heading, and inside it I'm gonna say change in the feature branch or the main branch, change in the main branch after the feature 2. Okay, so now let's save it, and these changes will not be reflected inside our new feature 2 branch. So after saving it, go to your Git and click on commit or stash. Here you have to provide a message, so I'm gonna say change after new feature 2. Okay, and then you can see that the branch is main, and I'm going to commit all the changes to my main branch. Okay, so you have to remember that right now we are working in the main branch, and all of these changes are being made inside the main branch. So now I'm gonna jump to the new feature 2 branch, and you can see that this is the code which is present inside it. I'm gonna copy it and paste it below this line and change it to new feature to started. And I know that it will cause merging conflict, but I hope that now you are able to actually resolve this merge conflict easily. So once this is done, save the changes, go to Git and commit or stash. Here you have to provide a message. So I'm gonna say added feature to code after commit or after branching. Okay, and you can see that this is being done in the new feature 2 branch. Let's go ahead and commit all the changes, and the commit has been made locally. So now if I go ahead and click on Git and see the manage branch options, okay, so you can see that now up till this point we were having the same graph for both of the branches, but now for the new feature branch after merging we have added feature 2 code after branching. But in the main branch, if I click on it, you can see that here after the merge branch new feature 1 we have changed after new feature 2. So after this point we have the differences. So now we have to actually merge the new feature branch 2 with the main branch using the dbase operation. But before that, if I move the solution explorer, you can see this red part which says that here is the new main branch, and if I click on the new feature 2 branch, you can see that this is the part which says that from here we have the new feature branch 2 code. So once you merge it, you will clearly see this red part showing where the main branch is started and where is the new feature branch. So now if you want to do the rebase operation, simply click on this main, right click it. Okay, so before that you have to change it to the new feature branch. So once you are here, right click on main, and then you have the option to rebase the new feature 2 onto the main. Click it and it will ask you to confirm it. Click on yes, and once this is done, you can see that the rebase operation completed successfully. Refresh it, and inside the new feature 2 you can see that after the merge branch new feature 1 we have a linear path showing change after new feature 2 and added feature 2 code after branching. And you can see that it has also shown us a local history that we added this, we updated the file and everything, and it has shown both of these things in a linear format instead of showing both of them as a separate path. So now once your rebase operation is done, you have to merge the two files or the two branches. So right now I'm in feature 2 and it is showing me to merge main into new feature, but we want to merge new feature 2 into main and it is not giving us the option. So from here I'm gonna move to my main branch, and now I'm gonna right click on the new feature 2 and select the option merge the new feature 2 into the main branch. Click it, it is going to ask for the confirmation. Click on yes, and you can see that the repository updated to commit. And now if I refresh it and just move it from here, you can see that it hasn't created any branch for us, rather it has created a linear history showing that after the merge branch new feature 1 we have a linear operations where firstly change after the new feature 2 was made and then added the feature 2 code after branching. And you can see that both of these branches name are appearing side by side instead of showing different branches. So this means that it has not created any new branch for the new feature in case of rebase operation. Rather, it created a linear history for us and showed that at what point the commit was made. So if I click on this, let's say I click on the main one, it is going to highlight the line and the statement or the chunk of code that was placed on this line. So this shows that this is the part of the main and this is the line where the new code line was added inside the main feature branch. So it created a linear history and combined the changes inside the main branch without actually creating a new branch inside this history graph. Okay, so this is how you can create branches in your repository and then merge the branches to the main branch using the merge and rebase operations. That's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you what are pull requests and how you can create and manage pull requests in your repository. Now that we have seen in detail that what are branches, how you can create branches, and then how you can merge the branch to the main branch using the merge and rebase operations. Now the pull request become much more important to be understood completely. So the pull request lets you tell others about the changes you have pushed to a branch in the repository. Once a pull request is opened, you can discuss and review the potential changes with the collaborators and add follow-up commits before your changes are merged into the base branch. In simple words, we can say that pull requests are a mechanism for a developer to notify other team members that they have completed a feature and added it to the main branch. So once their feature branch is ready, the developer files a pull request via their Bitbucket account. This lets everybody involved know that they need to review the code and merge it into the main branch. But the pull request is more than just a notification. It is basically a dedicated forum for discussing the proposed features. If there are any problems with the changes, teammates can post feedbacks in the pull request and even tweak the feature by pushing follow-up commits. All of this activity is tracked directly inside of the pull request. So whenever you make multiple branches to add new features, then using the pull request becomes very much important so that you can easily notify other team members working on the same application that you have added a new feature and that you want to make a commit of merging it to the main branch. So other team members will simply review your work and will approve or disapprove this merge, or they can also play around with your stuff to add a few other commits to make it more suitable for merging to the main branch. So now in order to demonstrate the pull request, I'm gonna delete this branch from here and I'm going to create a new branch and I'm going to call it pull request demo. It is going to be based on the main branch and click on create. So you can see that our branch pull request demo has been added. If we reload it, you can see that there is no history for this item, but if we click on the main branch, you can see that this is the graph for it. So now I'm gonna switch to the pull request demo branch from here and I'm gonna go to my HTML page. So this is the data which I currently have inside my pull request demo branch, and after that I am going to add a new h1 tag here and I am going to say let's say pull request demo to show that this is the code which is placed inside the pull request demo branch. So I have made a change to my pull request demo branch and let's say I am going to add a new h1 tag in which I'll say that I deleted the new feature to branch. Let's correct the spellings. And since these changes are made, we have to save it and commit it locally. So I'm going to go to the Git, click on commit or stash, and this is the branch on which I'm going to make the commit. You have to enter a message. I'm going to say pull request demo. Okay, so after this is done, simply click on commit all and you will see that the commit has been created locally for the pull request demo branch. And if I switch from the pull request demo branch to the main branch, you will see that all the new lines of code are not available in the main branch. So you have to remember that everything that I am doing right now and every commit that I am making right now is only stored locally on my local machine. People using the remote repository have no idea of what I am doing on my local system until I commit it into the remote repository. So now in order to actually commit all of these changes to our remote repository, we have to make a push request. So I'm gonna click on Git and select this push option from here, and you can see that pushing main has started and the task is running in the background. You can click it and see that it is writing 15 objects and the task completed successfully. So this means that our new pull request demo branch has also been pushed inside the remote repository. So now let's see that whether it is actually pushed to the remote repository. And for that, I'm gonna go to my remote repository, which is present in the Azure DevOps, and I'm gonna refresh the page of the repository. And in the branches, I have only the main branch. Okay, because I've selected the main branch to be pushed, let's select the pull request demo. And I'm gonna go to the Git and push it. So pushing the pull request demo is started and it is pushing it to the remote repository. Tasks completed successfully. Now I'm gonna go back and refresh it. And now if you drop it down, you can see that in addition to the main branch, you also have a pull request demo branch. And here it is giving you an option to create a pull request. So click on this button to create a pull request. So firstly, you have to provide a title for your pull request. So I'm going to go with the default, which is the pull request demo. Then you have to provide a description of what the users or the reviewers have to see for this pull request. So I'm going to say test how it works. And you can add any description to actually describe what you are doing inside the feature or how you are actually committing it to help the reviewers know what is happening inside the branch and what they want to test in it. And you can see that there are multiple options for the description. You can add certain files or you can add images, you can bold some part, you can create an ordered list, a bulleted list, etc. Then you have the options to add the reviewers. And here you have two options. Either you can add a complete group of users so that all the users present inside the group can actually review your pull request. Or if you want to get it reviewed from only a few people, let's say the manager of your project or the team lead, then you can simply pass their name for the reviewer. So right now I am gonna use my own username, which is this account, and you can add multiple users like this as well. And then you have the option to work items to the link. So if, for example, I was working on the student portal feature, so I'm going to select it that the commit that I've made into the main branch or the branch that I've committed into the main branch contains the code for this student portal. Then you have to check it, and then you have the option to add the tags of what this commit is actually doing and simply click on create. So once you do that, you can see that this is the interface that the reviewer is going to have. Since I was the reviewer, so I am getting this interface as well. So firstly, you can see that there are no merging conflicts, and then you have this description of what you have to do or what is happening inside the commit or the request. And then you have the option to add commits as a reviewer. So if everything looks good, you can say good job or give some appreciation to your team members. Or if you find any issues inside this commit, then you can write down all those issues. You also have the option to insert the file. You can add screenshots of the code chunks. You can highlight the important parts and everything else, and all the reviewers can do so. So once you have made it, let's say I am going to write the comment good job, and then I have the option to either approve this, approve it with suggestions, wait for the author, or reject it. And then you have the option to complete it, mark as draft or abandon. So firstly, I am going to approve it and save the comments. And once I do that, you can see that this user has approved the pull request. So right now there is only a single user. So it is only showing that this user has approved the pull request along with the comment that the reviewer made. If there were multiple members in the reviewer team or in the reviewer committee, then you will see the response of all of the reviewers here along with their comments. And once this is done, you have the option to complete it. Simply click on complete. And here it is going to ask you to select the merge type. And you have already seen these in the previous sections, but we have not discussed them at that point. So now I am going to discuss all of these in detail. So the first merge type is the merge no fast forward. It is equivalent to the simple merge where the non-linear history preserves all the commits. So this means that all the commits which were made inside the feature branch before actually merging into the main branch will be preserved and will be shown in the history. Okay, then we have the squash commit, linear history with only a single commit on the target. This means that if our feature branch has a lot of commits before actually being merged into the main branch, then all of those commits will be squashed and will be converted into a single commit, which will be shown at the end after the merging is completed. Then we have the rebase and fast forward. Rebase source commits onto target and fast forward. So it is going to show all the commits which were present inside the feature branch, but it is going to show it as a separate path, but only the most recent one will be showed in the graph. And then we have the semi-linear merge. Rebase source commits onto target and create a two-parent merge. So it is similar to rebase and fast forward, that it is going to rebase the source commits into a single one, and it is going to create a single target commit and create a two-parent merge. So it is going to create a path showing the branches, that this was the path that was made when we were working on the first feature, and the main branch will go on the other side, and then all of those will merge on the single point with a single commit. So for now, I'm going to select only the simple merge and click on complete merge. Once you do that, you can see that queuing project has been completed, and Andy completed this pull request. Now, if we go ahead and see all the commits from here, you can see this graph showing all the commits that were made previously. So from here, we started creating the commit. So this was the commit after branching. This was the commit when we created the new feature branch for the merging video. Then this was the commit for the merge branch. And again, this was when we performed the rebase operation to merge the branches, which was changed after the new feature 2, added feature 2 code after branching. And then when we created a pull request demo feature, this was divided into a separate branch, and then both of them merged into a single PR2 pull request demo branch. So this is how you can create different branches and create pull requests to actually approve your work by other team members before actually merging it into the main branch. So that's all for this video. I'll see you in the next one. Welcome back to a new section. In the first video of this section, I'm going to show you how you can create a TFVC repository in Azure DevOps and how you can actually connect your TFVC repository using Visual Studio. Azure DevOps supports mainly two types of repositories. The first one was the GitHub repository and the other one was the TFVC. So up till now in this course, we have been working with the Git repository, but now we are going to see how you can implement continuous integration with the TFVC, which is Team Foundation Version Control. So TFVC is a centralized version control system. Team members have only one version of each file on their development machine, and all the historical data is maintained only on the server. And just like you can create branches to add new features in the Git, you can also create branches which are path-based, which are created on the server. So the TFVC has two workflow models, the server workspaces and the local workspaces. So server workspace is like the remote repository or the centralized repository, just like GitHub, where all the final code is placed. And the local workspaces means each team member has a copy of the latest version of the code base with them, and then they can work offline as needed. After that, developers can check in their changes and resolve the merging conflict if necessary. So now let's see how you can actually work with the TFVC repository. So for that, you have to log into your Azure DevOps account. I am inside my school management system Scrum project, and from here I am going to add a new repository. Up till now, we have been selecting Git as the repository type, but now since we are working on the TFVC repository, so for the repository type, you have to select TFVC. Then you have to provide a repository name, and you can see that by default, it is disabled to be edited. This means that the repository name will be the same as your project name. And then there is a reminder that Visual Studio users will need Visual Studio 2015 Update 1 to view TFVC and Git repositories in team project that include both types. So this is a restriction that you must have Visual Studio 2015 update or later to have TFVC in their Visual Studios. Okay, so once this is done, simply click on create and you will see that your TFVC repository by the name School Management System Scrum has been created, and right now there is nothing inside the repository. Okay, so now let's see how you can connect your TFVC repository on your local system by using the Visual Studio or any other IDE. So I'm gonna open my Visual Studio, and from here you have to select clone a repository. And before selecting it, you can see that it says get code from an online repository like GitHub or Azure DevOps. So you can get data from multiple repositories, but these are the ones which are most supported by Visual Studio. So the first thing is the repository location. Here you have to either provide a path for your repository, or you have an option to browse a repository from either the GitHub or Azure DevOps. Since our repository is placed in Azure DevOps, so I'm going to click on it. And once you do that, you will have a dialog box that looks something like this. And from here, you have to select your account on which you have created the Azure DevOps account. And once you enter the credentials, you will get a list of all the projects and all the organizations present inside your Azure DevOps account. So you can see that this is the account, and this is my default organization in which I have the default project, and this was the sample organization that I created. And this is the third organization on which currently I am working. So it is School Management System Scrum, and inside it I have all these repositories. So since we are working on a TFVC repository, so I'm going to select it from here and click on connect. So once you do that, it is going to make a connection with the TFVC repository in Azure DevOps. And once your TFVC repository is connected to Visual Studio, you will see these different explorers on the Visual Studio. So on the extreme left, you can see we have the Team Explorer, in which we have different options. First one is the My Work, which I'm currently doing. Then there are the pending changes, which have been done on your local system but have not been committed yet. And then we have the Source Control Explorer, which is this option. Then there are work items. These are the work items that you have created in your Azure DevOps project, and you can link it with different tasks, etc. Then we have the builds, which indicates the latest builds that we have done in the project. And then we have different settings. And in the Source Control Explorer, you can see that School Management System Scrum is the project that we are currently working on. And in order to work on it on your local system, you need to have it mapped on your local system. So right now, this is selected, and you can see that beside local path, there is not map written. This means that this project has not been mapped to your local system. Right now, I have a single project inside my organization. So I am only going to map the project, but if you are working in the actual development environment where one organization have multiple projects, then you can also map your organization on your local system as a whole. But I'm going to map this project, so I'm going to select it and I'm going to click on not mapped. Once you do that, it is going to ask you to select a path where you want to map it on your local system. So I'm going to browse to my location where I want to store it. So I'm gonna go inside this folder and I'm going to select this folder here which says TFVC. Okay, so it is going to go inside my TFVC folder and is going to create School Management System Scrum project. Okay, so now let's click on map. And it will prompt you that newly mapped items will not be downloaded until you execute a get. Do you want to get School Management System Scrum now? So click on yes, and you will see that everything will be mapped to your local system. And now you can see that once your project is selected for the local path, you can see that this is the path where it is mapped. Now I'm going to click on file and create a new project on the same location where we have mapped our TFVC repository. So for the project type, I am going to select ASP.NET Core Web App and click on Next. And then for the project name, I am going to call it School Management System TFVC. Okay, then you have to select the location. So the location has to be the same where you have mapped your TFVC repository. So I'm going to browse to the location which is this TFVC folder, and inside it we have the school management system Scrum. Select the folder and simply click on next. Then you have the option to select the framework. I'm gonna go with the .NET 6.0, which is long-term support. Authentication type is none, and simply click on create. So once you do that, your ASP.NET web core application with the templates will be created. So I'm gonna come back once my project is created. So you can see that our .NET core application has been created. This is the Solution Explorer, and you can see that these are all the files that are created with it. Now, if I go to my Team Explorer and click on pending changes, you can see that here is a list of the work items. You can add different work items for your commit. So this check-in is actually equivalent to the commit in the GitHub. So you are actually going to commit all the changes that you have made locally to the remote repository or the server. Then you have the option for the included changes, and then you have the option for excluded changes. So right now you can see that there are no pending changes. This is because all of the changes have been added to excluded changes, and everything which is present inside the excluded changes will not be committed once you click on check-in button. So you have to add these excluded changes to the included changes. For that, click on the detected ones and click on this promote button from here. So once you do that, you can see that these are all the supporting files and formats and different patterns that were created once we created our ASP.NET core application. Okay, so all of these changes are now inside the included changes, and once I check in, everything will be checked in to your remote repository, which is present in Azure DevOps. And if you want to exclude any changes and you don't want it to be checked in, then you can simply select that option from here, and then you can move it to exclude. Let's say you can right click it and click on exclude, and it will be excluded from the check-in. Okay, so the next thing is, just like you add a message to your commit in GitHub, in case of TFVC, you can also add a comment. So I'm gonna say created files for app. Okay, so this is done. Now you can simply click on check-in, and it will ask you to continue the check-in 80 items. Click on don't prompt again and then select yes. So you can see that your checking in has started, and it is checking in 80 items at once. So you can see that the change set successfully checked in. Now let's go back to your Azure DevOps account, and this is the TFVC repository. So I'm gonna refresh the page, and now you can see that we have the school management system TFVC folder, which is present inside the repository, and this is actually the name of our project that we created on Visual Studio. If you click on this, you will see that these are all the files and all the folders which are present inside your Visual Studio project. So everything has been successfully committed, or you can say checked in to the TFVC repository. So this is how you can connect your TFVC repository to Visual Studio using Azure DevOps. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm gonna show you how you can protect your TFVC builds in Azure DevOps using the gated check-ins facility. In the previous video, you saw how you can actually create a TFVC repository in Azure DevOps, and then how you can connect it with Visual Studio. Now we are going to see how you can actually enable the gated check-ins to protect the TFVC builds via the pipelines. So as I have already discussed, that TFVC is a version control system, and it has a server workspace and the local workspace. And whenever a person works on the local workspace and he wants to check in his work into the server, then he uses the check-in option to do so. But sometimes the code might be broken or we have some errors, and without even building the project, the team member committed it or checked it into the server. So this may cause many errors for the actual code which is present on the server. To restrict it, you can use the gated check-ins. So the gated check-ins help you to restrict the developers from checking in a broken code into the source control system, and thus helps to avoid blocking your team. With gated check-ins, when a check-in is initiated by a developer, it will build the project and will check in the code only if the build is successful. So the gated check-in is suitable for projects whose overall build time is less than few minutes, because if it takes longer to build, then you might take a lot of time only to build the project for each check-in. So in short, we can say that gated check-in is a form of continuous integration build. In TFVC, it creates a shell set containing the code that is being validated and then runs a build of that code. Only if the code built successfully and all configured unit tests pass, then only it can be checked in or committed into the server. So now let's see how you can actually enable the gated check-ins for the TFVC repository. So for that, you have to create pipelines, because I've already discussed that we have two types of pipelines, the build pipeline and release pipeline. Because we are working on building our project, so we are going to use build pipeline. So for here, I am going to select new pipeline. So the first thing it is asking is, where is your code? It is a TFVC repository, so we are going to select Team Foundation Version Control from this list. Then you will be redirected to the page to select your repository. The source is TFVC and the workspace mapping has already been done. So this is the project that we are going to use. Next, then simply click on continue. The next thing that you have to do is to select a template for your pipeline. As I am working on ASP.NET Core application, so I'm gonna find the ASP.NET Core from here. Since I'm working on .NET 6, so I'm going to select this one. If you are working on any other technology, then you can select from these particular options. Simply click on apply. Then it will give us all the steps that it is going to carry out in order to build the pipeline. But right now we have to specify the agent, and from this drop down menu, I'm gonna select Windows 2022, because right now at the time of this recording, this is the latest version that is compatible with .NET 6. So once this is done, I'm gonna simply click on save and queue from here. Then you have the options to add a command to run the pipeline. You have the agent pool, agent specification, source version, shell set name, etc. So I'm gonna say TFVC ASP.NET. Okay, and I'm going to leave all other things to the default values and simply click on save and run. So you can see that the run has started and it is loading, and you can see that our agent job 1 has been queued. Now if I click on it, you can see that our job is running, and these are all the parameters that needs to be performed in order to build it successfully, and you should have a green tick beside all of this. There are green ticks beside all of these steps. This means that a pipeline has run successfully. Now let's refresh it, and you can see that this is the pipeline that I currently have. Now let's edit this pipeline in order to enable the gated check-in option. And in order to do so, let me first go inside my pipeline, and I'm going to click on edit the pipeline in order to edit the configurations of the pipeline. Once you are inside the pipeline, you have to go inside the variables, and then you have different pipelines variables in order to edit their values. Then the next tab is for the triggers. So once you click on triggers, you have continuous integration options and gated check-in options. So the continuous integration option enables you to set a time after which your pipeline will run automatically, and it is going to build your project and do everything that the pipeline is supposed to do. And the next option is for the gated check-ins. So you have a checkbox to enable the gated check-ins. After that, it will ask you to run continuous integration triggers for committed changes. You have to check that box as well in order to enable continuous integration. So basically, the gated check-in will check for any broken code whenever any team member tries to check in code from its local system into the remote server. And then you have the option to set a schedule for continuous integration, and you can set the time and number of days on which the pipeline will run on its own and will perform continuous integration. So you can set it or leave it as it is, and then you simply have to click on save and queue. Once you click on it, you have the option to add a comment for your pipeline. I am going to say enabled the gated check-ins. Now let's go back to our Visual Studio, and I've changed the theme to dark in order to see the code properly. So I have opened my index.c HTML file and I'm going to add a new h1 tag inside it saying gated builds enabled. And once this is done, I'm gonna go to my Team Explorer, and from here I'm going to check in all the commits from my local system into the remote server by checking all the pending changes and moving them into the included section. You also have to write a comment for your check-in. So I'm going to say testing gated check-in, and then I'm going to click on the check-in button. And once you do that, you will see a dialog box that says you need to build your changes for validation before they can be committed to the Azure DevOps server. So you must build your project in order to commit it to the Azure DevOps server. And below it, you will see two different buttons saying build changes and cancel. So you can see that in this way, the Azure DevOps has restricted us to build our system before committing it into the server. And this is because we enabled the gated check-ins for our build pipeline that we created in Azure DevOps. So whenever any developer will try to check in his code into the Azure DevOps server without building the code, then he will be restricted to first build the code and then check in into the server. Now let's click on build changes to build your project. And on the left side, you will see that your check-in has been queued for validation. Click here to see the status of the validation. And once you click on it, you will see the summary of your build request, and you are provided with a link. So once you click on the link, you will be redirected to the Azure DevOps, where you will see that your job will start to run once the build has completed. And if the build was successful, then it will successfully run the pipeline, and you will see that your school management TFVC has all the files and folders. And if you click on pages and go to the file index.cshtml, then you will see the new line that we have added from our Visual Studio has been added to the server as well. So this is how you can enable gated check-ins to protect the TFVC builds in Azure DevOps. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you how you can actually protect your main branch by applying gated check-ins to your Git repository. In the previous video, you saw that we protected the TFVC builds by enabling the gated check-in. So every time when the developer wants to check in his work to the remote server, then he must build his project and then he will be able to commit it. In case of Git, whenever a person commits something from his local system into the remote repository, then the commit is added to the main branch. And this should not be the case, because main is the branch that contains all the actual final code that must be error-free and must be kept safe. So everything should not be committed to the main. Rather, we should place check before committing the work into the main branch. So right now you can see that I am inside my Azure DevOps account, and I have opened the repository, which is a school management system. And this is a Git repository because now I am going to enable the gated check-ins for the Git repository. So once you are inside the repository, if you click on this drop-down menu, you can see that right now this repository has two branches. One is the main and the other one is the pre-production. Since we want to protect the check-ins or the commits to the main branch, so I am going to select it, and then from the left navigation menu, you can see branches written here. Click on it and you can see that these are the two available branches. This is the main branch that we want to protect. So click on these three dots from here, and if you scroll down, you can see that we have the branch policies. You have to click it in order to get to the settings for your branch. And once you land on this page, you can see that the branch policy option is not only available for the main branch, but you can also set it for the other branch as well. So let's have a look at the branch policies one by one. Firstly, we have require a minimum number of reviewers. So if you enable it, it will ask you to provide the minimum number of reviewers that must be required in order to approve the pull request. So whenever a developer will make a pull request, then at least 2 members must approve the pull request in order to allow it to be committed to the main branch. Then you have the option to allow requesters to approve their own changes. I will suggest you to not check this box. This is because if you set the minimum number of reviewers to be 2 and you allow the requester to approve their own changes, then one will be the requester on its own and he might ask someone to review it, and then the minimum number of reviewers will be set even though the code might have certain errors or the build might not be successful, but still his pull request will be approved. So you should not select this option. Then the next option is to prohibit the most recent pusher from approving their own changes, and this should be checked, but I am going to leave it as it is. Third, we have allow completion even if some reviewers vote to wait or reject, and then we have when new changes are pushed. So you can select any option that you want. Then we have checked for linked work items. So it encourages traceability by linking for linked items or pull request. So if you enable it, you have two options. Either you can select required or you can select the optional. If you click required, then it will block pull requests from being completed unless they have at least one linked work item. So whenever a person will generate a pull request, then he must attach a work item with it. Only then his pull request will be accepted, otherwise his request will be blocked. Then the next option is check for comment resolution, and then we have the limit merge type. I am not going to go inside the details of these. Then this is the important thing to see. The build validation, validate code by pre-merging and building pull request changes. So it is actually a policy that you can attach to your branch in order to protect it. So let me add a new build policy. Firstly, you have to select the pipeline that you have created for the branch. For my case, it is School Management System Scrum. Then you have to provide a path filter. I am going to leave it empty. Then you have to select a trigger, either automatic or manual. So automatic trigger means that your pipeline will be triggered whenever the source branch, which is main in this case, is updated. And if you select manual, then you will manually have to trigger the pipeline to be built. Then we have the policy requirement, and this is where you have to select the suitable option to provide protection to your main branch or to enable gated check-ins. So from here you have to select required, which says build must succeed in order to complete the pull request. So whenever a developer will make a pull request to commit his code to the main branch, then his build must be succeeded in order to complete the pull request. If the developer has not built his code, or if the build is not succeeded, then the pull request will fail. So selecting this option will enable actually the gated check-in in case of Git. Then you have the option for build expirations. Firstly, we have immediately when the main branch is updated, and then we have after 12 hours if the main has been updated. So I'm going to go with the default value. Then you have to provide a display name. So I'm going to call it build validation. You can give any name to your build policy and simply click on save. Once you do that, you can see that now you have a build validation that has an automatic trigger. And then we have the status check, requires other services to post successful status to complete the pull request. And then we have automatically included reviewers. So if you select automatically included reviewers, then you have to select a person name which must review the policy or the pull request before it is actually approved. So that person might be your team lead or some senior member of your development team whose approval is necessary in order to allow or approve any pull request. So you can add the people from here and he will be added to the reviewer list, but I'm not going to add it. So these are all the settings that you have to do in order to protect your main branch. So now whenever a developer working on his local copy of the code will try to commit his changes to the main branch, then firstly he will be asked to build his project before committing it. And if the build is successful, only then the changes will be committed to the main branch. Otherwise, he will be asked to make the build successful in order to commit the changes. So now let's quickly go to your Visual Studio, the IDE in which you are working. And this is my application that I am working on. Right now, I am inside the pre-production branch. But since we are working on the main branch and we want to check its functionality. So I'm gonna move to my main branch and this is the code which is present inside it. Now, in order to test the working of the restrictions or the policies that we have placed on the main branch, I am going to add a few lines which does not follow the syntax of C++, and here I am going to say applied build validation policy. Okay, so once you do that, you can see that this is not the syntax of the C++ and the application that we have created is a C++ application. So this is being done so that whenever we commit our changes, it will first ask us to build the project, and once we will build the project, then the build will fail and the commit will not happen. So let's quickly save these changes and I'm gonna go to the Git, and from here I'm going to click on commit or stash. And here you can see that we have one change in the main.cpv file. I am going to add a comment saying checking validation, and once this is done, you can see that this is the main branch and I am going to click on commit all. So once you do that, you can see that our local commit has been made, but now once I try to push it, you can see that it says fail to push the remote repository and see the output window for more. And this is because we have not built our application before pushing it. So now let's quickly go ahead and build the application. So I'm gonna go to the build and build the current document. And you can see that build failed. This is because of this error. So let's quickly go ahead and remove this. And instead of it, I am going to pass cout build validation added. Now let's go ahead and build your project. You can see that now our build has succeeded. Now if we go to the Git and click on commit or stash to commit the new changes, you can commit any changes that you want and click on commit all. You can see that the local commit has been created. Now if we want to go ahead and create a push request, simply click on push from here and you can see that pushing main has started. It is writing the object. So it is saying that you must use a pull request to update this branch. This means that you cannot directly make changes to this branch. So you must create a pull request if you want to make changes to the main branch. So let's say that we want these changes but you cannot add it to the main branch directly. So I'm going to cut these lines from here. I'm going to go to my other branch, which is the pre-production branch, and I'm going to continue to check out and I'm going to paste this line here. Now once this is done, I am going to save it. I am going to commit these changes to the branch by using validation comment. Okay, so it is saying that there are commits to resolve. So I'm gonna open the merge editor from here. These are the options, so I'm going to select both of these and I'm going to click on accept merge. So once this is done, place a semicolon here and I'm going to add the new line here. Now once this is done, I am going to save it, and if I open it a bit, now you can see that we have commit stage. So I'm going to simply commit it. Once this is done, I am going to make a push request. So it is initiating a push request to my pre-production branch. And after a while, you will see that the push has been successful to the pre-production branch. Now let's go to our Azure DevOps account. And if I refresh the page, you can see that I have updated the pre-production just now. So now what you have to do is you have to create a pull request. So I am going to say edit code for main. And then you have to add the description, which is not necessary. Then you have to add the reviewer. So I'm going to add myself and click on create. So now there are no margin conflicts and everything. Okay, it's asking that at least 2 reviewers beside the author must approve. So let's change this a bit. I'm gonna go to the branches, go to the main, and here inside the branch policy, I'm gonna change the policy to be off. Now go back to your repositories, go to the pull request from here, and this is the pull request. So I am going to approve it and I am going to complete it. Okay, so once you do that, you can simply click on complete merge, and it is going to merge it to the main branch. So once this is done, now you can go to the branches and you will see that instead of 2 branches, you have a single branch, which is just the main branch. So you can see that by applying the policy to the main branch, you were not able to directly make changes to the main branch. So instead, you first make changes to the feature branch, and once all the changes were successfully built and the pull request was approved by the reviewers, only then you were able to merge these changes to the main branch, and this is how you can protect your main branch. So that's all for this video. I'll see you in the next one. Welcome back. In this video, I'm going to show you how you can create your release pipelines for your .NET web application and deploy it on Azure DevOps. Previously, we have seen what are release pipelines, but we did not see how you can actually create the release pipelines. In this video, we are going to see in full detail how you can actually create your release pipelines by using it with the build pipelines. So before moving towards creation of the release pipelines, let's first go to the branches, and I have disabled all the policies that I added to the main branch in the previous video. This is because we want to have everything work smoothly while we create our release pipeline. So from here, I have removed the required minimum number of reviewers, and also I have disabled the build validation policy that I created in the previous video. So in order to create a release pipelines, you have to go to the pipelines, and from here you have to select releases. So I already have a release pipeline that I created previously. So let's just go ahead and delete it. And as usual, provide the name of your pipeline in order to delete it and click on OK. So now we have absolutely no release pipelines. So to create a release pipeline, we are firstly going to click on New Pipeline, which will give us this wizard asking us to select a template. And you already know that this tooling is not limited to only .NET development. You can set up and release pipelines for almost any development environment. So to get through this particular activity, for this pipeline, I am going to select Azure App Service Deployment. So this means that I'll have to go to Azure, set up a service, and then every time we do a build, then it must go to that app service. So I'm going to apply this one. So firstly, it is asked us to provide a name to the stage. I am going to call it deploy to Azure App Service. Now let's move ahead from here, and now we have to select an artifact. So an artifact is a set of files that represents the version of the application which is about to be deployed. So I'm going to click on add an artifact. You can see that you have a wide variety of source types. You can add build, you can add Azure repositories, you can add the artifact from the GitHub, from the Jenkins, the Docker Hub, etc. But for now, we are going to stick to the build, and below it, we have the option to select the project. We'll select School Management System Scrum, and then you have to select the source, which is actually your build pipeline. So you can see that here we have two build pipelines. First one is the School Management System Scrum, and the second one is for the ASP.NET Core application. I want to use the Git one, so I'm going to select School Management System Scrum. Then you have the option for the default version. You can see that there are multiple options. Out of these, you can select any one according to your requirement. I'm going to go with the latest one. And then you simply have to click add. So here we are actually defining that this is the artifact that we have to get as a result of deployment to the Azure App Service. You can also set up a schedule for the trigger. You can add any different days of the week, and you can also set the time for the trigger. So every time you reach that time of the day and that day of the week, then your pipeline will automatically be triggered according to the schedule. I'm going to disable it because I don't need the trigger to be scheduled. And the most important thing that I want to look at is the continuous deployment trigger. So once you click on that lightning bolt, you will get this option or this wizard from where you can enable or disable it. So from here, I'm going to enable it, and it says creates a release every time a build is available. Then you have the option for the pull request trigger. So enabling this will create a release every time a selected artifact is available as part of the pull request workflow. So I'm going to leave it disabled and I'm simply going to enable the continuous deployment trigger only. Then simply close it and now you have the continuous deployment trigger set up. So up till now, we have enabled the continuous integration. This means that whenever a new build is available, we are going to integrate it with our code. And then we have the continuous deployment, that whenever we have a new build, then we are continuously going to deploy it on a service. Now let's move to the next step, in which I have to view the tasks that are available for the stage. And to do so, in the top, you can see that there are tabs. You have to click on the task tab. So here it is asking that if you want to deploy to Azure App Service, then you need to add your Azure subscription. So from the available subscription, I am going to select the suitable one and authenticate it. So after authentication, you are good to go. Then you have to select the app type. I am going to leave it to the default value, which is the web app on Windows. Then you have to provide the app service name. I have a few app services, but I have not created an app service specifically for this. So let's go ahead and create one. So I have opened my Azure account and from here I am creating a web app. So after the subscription, you have to provide a resource group. I am going to create a new resource group and I am going to call it School Management Demo. Then you have to provide the instance details. So for the name, I am going to call it School Management App and there shouldn't be any special symbols. Then you have to select code to be published, and for the runtime environment, since we are working on .NET application, we are going to use .NET 6. For the operating system, you are going to select Windows and then you have to select the region. I'm going to select East US 2 region. I'm not going to change the app service plan and I'm going to leave it running on the free tier because I have free tier running right now. And then simply click on review and create. Okay, so the web app has been created. Now let's jump back to our Azure DevOps account. Refresh the page and you can see the service name appearing here. So if I go to my Azure account and I run the web app, this is what it is looking right now. Now let's just go ahead and save it and I'm going to call it setup release pipeline. So now if I go to the pipeline and click on releases, I can see all of the release pipelines and from here you can simply click on create release to run the pipeline. But I want to edit that, so let's click on it and I'm going to change the name of my pipeline to Azure App Release. Save it and now you can clearly see that what this pipeline is actually doing. So it is an Azure App Release pipeline. So I can create a release manually and for that I'm going to click on create a release button. And from here it is just verifying that it is going to run on this particular stage, which is deployed to Azure App Service. Then you have the option to change the trigger from automated to manual. And right now we have a single deployment environment. So it is showing only one option and you can simply check and uncheck it to add it to manual trigger. But if you have multiple stages, then you can select some of them to be in the manual trigger and remaining will be in the automated trigger. So I am going to check the deploy to Azure App Service because I want to do it manually. And once this is done, simply click on create button. So once you click on create, it will create a release, but nothing is actually going to happen because I said that I want to do it manually. So now it is showing me that the release has been created, or we can say that the history of release has been created, but nothing has actually been done because I said that I want to trigger it manually. So as I have already discussed that you may have different stages or different development environment where you want to stage your pipeline, but right now I have only a single one. So if you have multiple stages, then you can see that there is not deployed option by the side of them. And if you want to select or manually deploy any of them, you simply have to click on it and then click on deploy. And it is going to show you a wizard that looks like this. And inside the wizard, go ahead and click on the deploy button. And it is going to be queued and you will see that the gates are processing. And you should see that the same agent that was handling our builds is also going to handle our deployments. And you can also see that it is going to take some time for the deployment. This is because the hosted agent has shared resources, and I am also working on the free tier of Azure, so it is going to take quite some time to do it. Okay, so when it finally gets started, we can simply jump over to the logs and see what is actually happening. Let's go to the agent logs and deploy to Azure App Service. And here you can see a summary of everything that it did. So here are a list of all the files that have been in the deployment. Some are our project files and some are other files which are necessary for the deployment. So you can see that everything has been successfully deployed, and it is also given us a URL for the application. So if I jump to this URL or copy it to my browser, and if I run the URL here, you can see that this is the application that we created on the Visual Studio using the .NET Core web app. So you can see that it has been successfully deployed. So this is how you can create release pipelines for your application and then deploy it on Azure DevOps. So that's all for this video. I'll see you in the next one. Welcome back. In this video, we are going to be testing the automated release pipelines that we created and deployed in the previous video. In the previous video, you saw that we created a release pipeline and then triggered it manually. In this video, we are going to test how the pipeline actually works when we make certain modifications in our code, and then when the code is committed, then how the build works and how the release happens automatically. So I am going to make a simple code change from right here in my Azure DevOps. You have to make sure that we are currently working in the main branch. Then I'm gonna go inside my index.cs HTML file, and I am going to copy and paste this line in this file. And make sure you are in the edit mode and you have edited the file. You can add any line you want. The only purpose of doing so is to make some changes in any of the files of our application. And once you click on save, you will see that it will trigger a job. And the job is actually going to be the build job. So the job will actually run the build pipeline, and we already know what will happen in the build pipeline. And you can see that there is written attempt number 2. This means that for some reason the first attempt was timed out and now it is again trying to run the job. So this is the best part about the jobs, that whenever your job or the build fails, you can always go back and rerun it, and it will continue to run from the same point where it failed. Now, after that build pipeline has successfully completed the job, it is going to trigger the release pipeline. So now when I jump over to my releases page, here you can see that I have a release 2 which is failed, and it is also marked as abandoned. And then you can always go to the release and then view the log by clicking on the stages. So in the logs, you can see that it failed to connect to the resource in Azure. So it may be due to 2 pipelines were triggered at once, and due to the limitation of resources, I think this issue arises. You can click on logs and view all the issues and the warnings that you want. So once you go into the pipelines, you can see that one build was failed and I have another build which was successful. The first one failed for some reason, but for the second one, this is the build and it succeeded. So once the build was succeeded, now it triggered the release pipeline. So let me show you that from the build pipeline. So if you click on the build pipeline, you can actually select the change that triggered the pipeline, and then from the tabs you have to go to the releases tab. And here you can see the release which is associated with the build trigger. And you can see that the release was the Azure App Release 3, which was a successful deployment to the Azure App Service. So now when I refresh the page where I have deployed my website on Azure Web App Service, I should actually see a new H1 tag saying testing release pipelines. So let's refresh it. And there we go. Here we have the testing release pipelines. This means that our changes have successfully been built and released. So this is how you can keep your application up to date by integrating continuous integration and continuous deployment with it by using the build pipeline and release pipeline. So whenever a user will make any change to any file of the application, it is going to trigger the build pipeline for us, and once the build pipeline will be successful and the build job will be successful, then it is going to trigger the release pipeline, and the new changes will be released to the environment which you have selected for the deployment. So you can see that we have successfully tested that our release pipeline has been automated and is being triggered right at the time when the build is successful. So that's all for this video. I'll see you in the next one. Welcome back. In this video, we are going to talk about what is a deployment group and how you can add machines in the deployment group and then deploy your application on the group. Okay, so let's talk about the deployment group first. So a deployment group basically represents a physical machine that you will be deploying to. So in order to create a deployment group, you have to go to the deployment groups from the left navigation menu. And once you land on the page, you can see that I have already created a deployment group. So let me just go ahead and quickly delete it. So a deployment group defines a logical group of target machines for parallel deployment. So this comes in handy when you want to deploy to one or more physical machines. This means that if you have multiple machines, whether they are virtual machines or the physical servers, but the fact is that they all may be running the same application that you are going to deploy onto it. So when you actually do a deployment, you actually don't want to do the manual effort of doing it to one and then doing it to the other machine. So with Azure DevOps deployment group, the Azure DevOps will take up that operation. It will look at the machines which are present inside the deployment group, and then it will make the deployment of all of the machines simultaneously, and then everything will be on par all at once. So this is the main usage of a deployment group. So let's just go ahead and add a deployment group. So I'm going to click on add a deployment group button. So firstly, you have to provide a name to your deployment group. I'm going to call it School Management VM. As I have already discussed that a deployment group may have more than one machine. So I've already moved to my Azure account and I have created a virtual machine. And this is being done just for the demo purpose. In real scenario, it can be any machine or any server that you want to deploy your application to. Let's go back to Azure DevOps and I'm going to click on create button. And then once you do that, it is going to ask you to select the type of target to register. It may either be Windows or Linux. I'm going to leave it to Windows. And I'm also going to check the box that says use a personal access token in the script for authentication. And for that, I am going to copy the script to the clipboard. And then I'm going to go back to my target machine. So I do have my virtual machine running right now. So it is basically a Windows 2022 server that I have provisioned, and I'm going to bring up the PowerShell. And make sure that you are running the PowerShell in the administrator mode. So here I'm simply going to paste the script that I've just copied and I'm simply going to hit enter. And I am getting an error. Okay, so it is saying that there is some syntax error in the script. I'm not sure how it got there because I've simply copied the script from the Azure DevOps. Okay, so I think that from the script, the administrator should be within the quotation marks. Okay, so let me just go ahead and edit it. So I'm going to open the notepad. I'm going to paste the script in the notebook, and then I'm going to find the occurrence of the word administrator. And I'm going to enclose this administrator within the double quotes. And then I'm going to copy all of this. I'm going to go back to my PowerShell and paste the script there. Now let's just go ahead and hit enter again. And you can see that now it is running. So let's understand what it is doing right here. So once you hit enter, you will see that it is actually installing an agent on our machine. So you can have multiple machines at the server, and all the servers will have a copy of the agent on them. So if you go to that location, you can see that I have already so many agents. So let me select the one that it have just created. And you can see that here is the agent that is being installed, and it is A4. And you have to make sure that if you are going to deploy a web application on the server, then it must have an IIS. So if you are not sure how you can actually install IIS on your virtual machine or the server, you simply have to click on add roles and features, and then from the roles page you have to select IIS or the web server IIS, and then you can follow the instructions accordingly, and this is how it will be set up in your machine. Okay, so if you go back to your PowerShell and you hit enter again, you can see that now it is continued running, and these are all the things that it is showing. You can see that here it is asking if you want to enter replace. I'm not totally familiar of what it does, so if you are not sure to, you can simply press Y to continue it. And then it is going to ask a more familiar question, which is enter deployment group tags for the agent. So you simply have to press Y or press enter, and it is going to successfully replace the agent and testing the agent connection. Then it is asking some other questions about the permissions of the machine. So simply go ahead and hit enter, and it is going to take actions accordingly. And then it says enter whether to prevent service starting immediately after configuration is finished. So I'll just press enter here, and there we go. So now this agent has been configured to liaise between the Azure DevOps and our machine. Now if you go to the services, you are going to see Azure pipeline agent, and the status of the agent will be running. So if we now go back to our Azure DevOps, and if we refresh the screen and let's just go to target from here, you are going to see that the deployment group is healthy and it sees the machine that we have just created. So once that service is running and it is able to connect, then everything is fine. So from here, from the targets, you can actually see all the machines and the status of all the machines, that which of them are healthy and which of them are not. So now let's just go ahead and modify our release pipeline to actually deploy the application on our local virtual machine as well as on the Azure Web App Service. So I am simply going to edit my release pipeline, and firstly I am going to change its name to simply app release. So now if I want to add a task or a stage after a task, then I simply have to click this plus sign below it, and it is going to create a new stage for us. However, if I simply want to create another stage that has no linkage with the previous stage, then I can simply click on this add button beside the stage and create a new stage. And now the two stages will be independent of each other, which previously were in a linear formation. So now the both stages are available parallel to each other, and they can also run in parallel. Since I am using a web application, so for the template I am going to select IIS website and SQL database deployment, and I am going to click on apply, and then I am going to name this stage to server deployment. So now let's go to the tasks of the stage, and for these tasks I am going to remove the SQL deployment. So now we'll simply focus on the IIS deployment, and we are going to address all of these red areas. So first of all, we have to provide that what is the deployment group. So from the drop down menu, we are going to select our deployment group. Then you have to select the number of targets to deploy to in parallel. You can select one target at a time, or you can select multiple. So it means that if we have more than one machine, let's say we have 5 machines and we want to deploy the application to all of them at once in parallel, then you have to select multiple and then select the number of targets in parallel. Okay, so I'm going to select multiple, and then we can see that the artifact is coming from the build already, and I think we are done on the screen. So now let's select the second option. So it is asking what is the website name. So let's just click on server deployment, and here we have the same option. So for the website name, I'm going to say school management system. Then I'm going to add bindings, which will allow me to assign it the default port. So I've placed 80 here, and then you have to select the IP addresses. So I'm going to go with the value all unassigned IP addresses. So let's just keep it at bare minimum to make better understanding. And then you have to provide an application pool name. So I'm going to give it the same name as my application or the website. So now you can see that with all of these changes, there are no more errors in our server deployment. So now let's quickly come to IIS web app deploy. So here in the IIS deployment, you simply have to define the machines that fall into the deployment group. So in the IIS web app deploy, you can see under the package of folder, it is the path where you can actually get the artifact, and it is actually what it is going to place in the www.root folder. So now once all of this is done, I'm simply going to save it and I'm going to add a comment, edit server deployment group. So once again, I'm going to test my pipeline again. So I'm going to go to the files and I'm going to go inside the index.html file and I'm going to edit it once again. I'm going to add a new h2 tag. And inside it, I'm going to write testing deployment group. And then I'm simply going to commit it and allow the build pipeline to run and then trigger the release pipeline. So now I'm simply going to pause the video and I'm going to come back once it goes to the release pipeline and we are going to see everything from here onwards. Alright, so now if we watch the releases from here, you can see that deployment to your app is actually processing the gate, but the server deployment is actually in progress. So let's jump over and view the logs for the server deployment. And now by simply hitting the play button, it is now showing that it is downloading the artifact and it is also doing all the IIS operations that needs to be carried out and it's failed. And it is giving a binding error and I think it is my misconfiguration because it is saying that port 80 is already running for a different website. So I can't actually deploy a new website on the port 80. So I'm simply have to go back to the release and then I'm gonna go to the task and in the server deployment, firstly I'm simply going to change the name and I'm going to say default website. So once you do that, you don't need to change the port because you can see that in the error it shows that default website is running on port 80. So we are going to use the same to be run on the port 80. And for the application pool name, I'm simply going to call it default. Now simply save it and I'm going to add the comment fixed IIS website error. So now I'm going to manually trigger the release pipeline because we already know that the build pipeline is successfully working and it is triggering the release pipeline. So instead of going through all of this, I'm simply going to cancel the current running of the release pipeline. And then from the releases page, I am going to click on create a release. And I've already showed you that if you have multiple stages, then you can select some of them for manual triggering and then some of them to be automatic triggered. So I'm going to select all and it is going to select all the stages to be manually triggered and then click save. So now you can see that it has created a release 5, but nothing is actually happening because I have said that I am going to trigger the release manually. Now I can select the one that I want to do manually. I'm not going to deploy the Azure App Service one because I know that it is working fine. We have to check the deployment to the server. So I'm going to go to the deploy or for the deployment server and click on deploy. And then from here you simply have to click on deploy. So you can see that the server deployment is in progress and we can simply jump over to the logs by clicking the play button and see the progress for the deployment. And yeah, you can see that now we have a successful release to our server deployment. Now if I jump to my server or the machine that was the target for the deployment, and let me just go to my file explorer and go to the location where the agent was installed. But instead of that, click on inetpub and click on the IIS folder, which is www root folder, and scroll down and look at the files that have been created or installed as a result of deployment to our server. So let's see what comes up when I try to browse the server. It is giving me an error and this is because the environment has not been fully set up because I have not actually configured the .NET environment on this server. And even if I set that environment and it may run the .NET Core web app, but the application might have some links to any database environment and that has also not been configured on the virtual machine. So if you are working on a real-time environment in which you actually have a machine that have all of the configurations for the databases and for all the runtime environment, then doing all these steps will successfully deploy your application on the web server. So you simply have to follow all of these steps and your deployment will be done. So that's all for this video. I hope you got some knowledge about the Azure DevOps and how you can use different features of Azure DevOps, about the organizations, the projects, how you can use the groups, you can create the pipelines, use the artifacts and create build and release pipelines to integrate continuous integration and continuous deployment for your project. I hope that you learned a lot from this course, and this course will be helpful for your future endeavors. Thank you.